development side also, I mean, I can answer it then too. So that's a quick intro about me. So just to set the expectation for this today's session, this is towards a 40-minute session, but we are not going to do any technical, deep dive into any of these tools in this session today. So this is, a decision making as a business leader, or selecting a architecture or an infrastructure, how the governance will help the AI applications, and how can we scale up. These things will be more discussing in today's session. I request the session to be more interactive, where you can ask me more questions. That way we can get more insights of the session, right? So as said, the expectations are, this is not a technical or a hands-on or a demo kind of a session. Most of my sessions, let's say 90+% of my sessions, are normally a technical sessions and a hands-on demo kind of a sessions. But this is a one only session what we have for digital enterprises transformation. So today will be more theory, and we'll be more talking about case studies. But we do have another module separately with a 40 hours of a session. Maybe in another 1.5 months to 2 months, I'll be coming back to you again, and I may be more deep diving into cloud strategies. Rest all infrastructure requirements. How can we implement AI applications? How do we do a build a product in AI. So all these things I'll be more deep dive, in upcoming sessions. But today it's not, hands-on or demo, right? And we'll be more talking about benefits of enterprise digital transformation, and why AI can't scale without cloud. These things will be more understanding in today's session, right? So what we need to understand is, previously, when I say, when we talk about as an IT, I used to be a IT head in a few organizations previously. So when I say cloud, we used to consider that as an infrastructure basically previously. So do we need to go with a cloud infrastructure or a on-prem infrastructure when we are developing a product, or when we are developing an application, or building an application, or when we are going for a go live or a product development? This is where we think about, do we need to go for a cloud? Do we really need a cloud, or do we need to go with an on-prem? Kind of a discussion used to be there previously, but that got changed now. So we are, let me select that as a question. Oh, it's okay. There is a chat. Fine. So, cloud is not any infrastructure kind of addition anymore. This is a strategic business platform which is really required for AI implementation nowadays. So, if I'm just thinking about AI, forget about on-prem development, totally. So, it's all about cloud only nowadays, right? And how it helps, how it can be scaled, how is different on all those things we'll be more discussing in today's session, right? Now, also just want to set the stage here. First point, I just want to let you know, there may be a CIOs, there may be a CTOs in this session, or a core technical guys like IT heads. If you are in this session, I'm sorry, you may feel that, okay, I may know all, I know all these things, but this session is more for the business leaders who are not really into technical, and who are very new to AI and very new to cloud and infrastructure. For them, this is going to be more interested, and this is very helpful for them. And I want everyone to be on the same page, and from there I can, we can travel towards AI on cloud, or how can we implement AI on cloud later, right? Also, I request, if you are already a tech guy and have a deep understanding of all the cloud and technologies, then I request you to add to me if you have any points, so that that will be more helpful for other participants in the cohort, right? So I hope you will be supporting this thing, and you can always counter. You can counter me if there are any points, if I'm moving outside of the topic, or if you feel that is not relevant, right? Great. With that, let me get into the session. AI is transforming industries, but infrastructure bottlenecks can slow down the adoption. So you know we all know that nowadays, everything, when we go to the market, every industry, every, you take a healthcare, you take a retail, manufacturing, any industry you take, people are talking about, or the industries or enterprises are talking about, how do we implement AI, right? So when they are talking about implement AI, what exactly they mean, get some insights from the data, right? So, however, what is the way is totally different thing, but get some insights out of the data, and also where the artificial intelligence can take some decisions. Like, I'm talking about an agents, AI agents, which we are currently, looking in. So where AI can take a decision instead of a human, right? So to go into that era, or of course, we are into that era, of course, right now, but to move our enterprises digitalized into that era, definitely we need a proper infrastructure planning also, right? So that's where the organizations, or the applications or the products are getting slowed down because of infrastructure is not provisioned correctly for AI requirements. That's one thing. And business leaders must align with AI strategies, like say the scalability, the cost effectiveness, and also the secure infrastructure, right? So when I say secure infrastructure, we do have a security when we are building applications on-prem, but what kind of at what level we have a security is the matter there. So we normally have maybe, like say, a physical security, and then followed by a network security, and then followed by a server wise security, three layers. But there are many more security layers in cloud, where we can more secure our applications on cloud. In fact, like say a decade back, there is a good debate between the IT industry itself. There is a security issues when I move my data to cloud. Is my data secure, or is my application secure? Is my data not copied or leaked by my applications to other parties? Kind of myth is there, but that's totally gone now. And even banks, or the healthcare systems, are trusting cloud nowadays and moving towards cloud. Okay. So I recommend all the AI leaders, or the business leaders who are getting into the AI now, recommend cloud, trust cloud in all the ways, and which we can also understand in the upcoming sessions, how the cloud is going to be more trusted than on-prem now, right? So digital transformation has shifted from digitization to intelligence. You know what? 15 years, or when these computers came in, previously, we used to maintain these ledgers, accounts on papers, or that's where, when we are moving on from papers to computer, that's where we call it as digitalization at that time. Okay, digitization at that time. Now that's no more. Everything is on computer systems nowadays. So now what I mean, or the industry mean, the digitization or a digitalization is getting some intelligence out of from that data. So when I say intelligence, you can consider it as like, we are generating data. From that data, we need to tune and then get some information, some insights, okay, some intelligence from that data. That is what we are more talking about when we say enterprise digitalization nowadays. So that's what I just want to mention here, shifted from digitization to intelligence, right? So the digital transformation is now intelligence, basically, not only, or not still, the digitization, right? So AI success depends on scalability, governance, and repeatability. So scalability, repeatability will be a normal, people used to understand that clearly, but I'll be more talking about them again. But governance is also a very important factor, success factor, when we are moving or when we are implementing AI applications. And we'll see how, this governance is playing a big role. Now, as I said before, cloud is no longer an infrastructure, it is an enterprise capability. It's a business decision which we need to take, at starting our product or a startup, or, in the new, in the enterprises too. So cloud is into the organization, right? So this is what we'll be more talking today in our session. And before waiting to the session, the actual slides, just want to hold for a minute and ask if there are any questions, if you have, before moving into the session. If there are any questions, if I just want to answer, if the slides are there for that, I'll let you know that, please hold for 10-15 minutes where you'll be understanding more about that. But if it is not there, I'll be addressing now, of course. Yeah, if you have any questions before getting in.
Well, one question, sorry. As you just mentioned that all the organizations, be it a small scale, mid scale, or very large, cloud computing is now the necessity, right? Because we cannot think of our business running as it was running 15 years back. But there are certain factors which I believe should be the criteria to define whether I should go for the cloud, or I should be with my in-prem resources. So, for example, in case if I'm having a data set which is not too much, which is not too big, and I'm I'm okay with all the infrastructure that I have already with me and running successfully. Do you think in that kind of scenario, should I acquire the cloud,
Right.
or will it make sense to me for for a small organization? It's not very big organization.
Right. See, we have at every level, like say when we are building or when we are developing a software application, first of all, we will go through some prototypes and we'll understand how this application will help me to the business. What's the ROI in this particular application? Okay, return on investment. So, which is a very big criteria, when we are moving to cloud. So there will be a, whenever we are planning the entire enterprise or maybe a small organization moving towards cloud, for, cloud first is what, we build a team, a 2 or 3 members team, and we'll understand why do we need a cloud now, what we are going to plan to run on cloud, how it is going to be helpful for the organization. All these things we will go through, and we'll see if there is any, if there is an ROI or not. If not, then definitely, cloud is not a 100% solution there. Now, coming back, as I said before, when we are implementing AI and there is a real-time data coming in, and if there is a huge data sets, and, we want to give a, access to our customers who are accessing our application online, then in that case, AI should be on cloud. But if it is a batch processing kind of a thing, and a monthly ones, should be sufficient for me, that insights can be surveyed for my next 1 month, of course, then in that case, really not required. Yeah. Does that, answer your question? Right. Thank you, girls. Yeah, there are a few more questions. Nimesh, please go ahead.
Yeah, Professor. When we say that there are infrastructure bottlenecks, could you elaborate further on that? Like, what does that mean? Is it like not enough cloud space is available? Like, what does that mean when we say there are infrastructure bottlenecks?
Right. So when I say infrastructure bottlenecks, like say for example, there is a AI model which, you developed, and you need to train your model with a huge data. So just to train your model, if you want to build an infrastructure, or you need to procure an infrastructure on-prem, which is really not required, right? So, because the infrastructure is a temporary requirement there. So what organizations will be doing? Let us go with the minimal, infrastructure, whatever I have, like say a 62 GB RAM with having a, 40 core vCPUs with a, 1 TB of a storage. Let me continue for this infrastructure for 1 month of implementation so that I can solve my problem, right? Whereas if I go to cloud, okay, by implementing my AI or machine learning model on cloud, so no need of procuring anything, because it's a pay as you go mode. You hire the services, servers, like say for the the time being where you are running your training, right? Like say you executed your training, or you started training and completed within 10 days, and you'll be paying only for that 10 days for your infrastructure. And that infrastructure you can scale at any point. There is no limitation there. You can go like a 126 GB of RAM with having a 60 core processor. There is a scalability available. Options are there which will solve all your issues, and within 10 days you can close it, instead of running for waiting for a month to execute with a minimal infrastructure. That's where infrastructure bottlenecks are these things. Not only this, and if say not only for training, there are many other cases. I'll be talking more in my upcoming slides, where I'll point every time the bottleneck going forward.
So it means as people start to move more and more towards cloud, I think this infrastructure issue will get resolved, is what you're alluding to.
Exactly. Yes.
Okay, got it. Perfect. Thank you.
Thank you. Yeah. Please go ahead. Barbara, please.
Badr speaking here. Yeah. Just back to Prince's question about the system itself moving from the classic to the AI. Can we consider also the TCO also in the? You mentioned the ROI. Can we consider also TCO in case if we want to move from the classic to the AI?
Yes. So you mean, can you repeat that question again? I missed that part.
The same question of Prince that he's mentioned. I have a system now. Why I should move to the AI or shift this or transfer the system to the AI?
Right.
So you mentioned the ROI. I should consider there. Can we consider also the TCO in this case also as a factor also for us?
There are many other factors. There are many. I just mentioned only one factor. We build a team cloud first. We name it as a cloud first, and we have a certain policies which we need to follow there. And if all the policies are satisfied, then we'll be going to the cloud. And if some are compromised, then still, if business says okay, we'll be moving to cloud. So within that, all these comes into the picture, TOC and all. Yes.
Can we consider also something like expanding the system if for future work, keep moving the system from the classic to the AI, so the system will be more
Yes.
ready for the future?
Yes, ready for the future. Like say, let me give you a few more examples. Like say, for example, my infrastructure is in on-prem in India, but my customers are more from Singapore. So there will be a latency from Indian servers to Singapore because there are multiple hops in between. So if I can place my infrastructure on cloud, and if I can have a CDNs, like say content delivery networks, where my CDN is it in Singapore, and where some CDN is also in US, UK, like that. So based on that, my customers will be accessing directly without having any latency. That is another thing. And if there is any heavy load on my on my application, like say, let me give you one quick example. Like Amazon Thanksgiving Day, e-commerce website. So on a Thanksgiving Day or any festival day, there will be a heavy load on the application. So if my application is hosted on-prem and I want to connect such sales thing, then yeah, I need to expand my services, or I need to expand my infrastructure, which is not possible on-prem. If it is on cloud, I can expand that for the first the 3 days or 4 days, and then immediately I can get down to the regular business after 4 days. So the cost is only for my that first 3 or 4 days where I'm running my sale basically. So these are multiple things where we plan before moving to the cloud based on our business requirements.
Perfect. Thank you very much.
Thank you. Yeah. There is another question. Someone raised hand but lowered. Okay, that's fine. Any other questions? If not, I'll move it.
So one of the other benefits that people talk about more from a business strategy standpoint, on-prem versus cloud, that I've always heard is that on-prem is like an investment, a one-time capital investment,
Correct.
right? And so it influences your accounting policies in a different way because you account for depreciation of the assets over the years,
Correct.
right? And you have to carry it as an asset or a liability in your book.
Correct.
While cloud computing, because you pay as you use, it is more of a variable cost and hits your P&L in the same year.
Correct.
So that sort of influences your total cost of ownership in a different way
Correct.
in terms of and your profits as well is what I get to hear.
Exactly. So that's what I mentioned in my previous answer. Instead of procuring all the servers on-prem based on the requirement, if I can go for a cloud, I can use them and they can, pay based on my usage only. So the differentiation between these two is that the first one is a capex, where we, invest all huge amount to procure the infrastructure, and down the line, like say 3 to 4 years, the servers are really not supported for the at that time application requirements, and that's a loss basically. So if it is a opex model where you pay as you go, and where, as you mentioned, within the same financial year we can close all the P&L, all the invoices in that month, in that year itself, that makes even profitable for the organization. And even for the projects, this is a business side, but even for the projects, like say, as I said before, for training purpose, or like say to build a POCs, any startups or a small organizations or any enterprises have in individual departments, if they just want to build a POC, instead of going to their sales, their procurement team, and ask for, this is what we are planning and we need to purchase all these infrastructure, they won't allow, because they won't see the ROI upfront there. They don't have a confidence on us. So what we can do, simply we can go for a cloud environment and simply invest, like say a month, or a 2 weeks or a 3 weeks POC cost, and get the output there. And then with output, if I can go to the procurement and say, this is what I got the output and this is what the ROI. And if we can have cloud environment on a monthly basis, this is what the recurring cost is. We can go with such proposals to the procurement team within the enterprises.
Thank you, sir.
Yeah, thank you. Let me know. Yeah. So benefits of enterprise digital transformation. Just want to talk about a few pillars here. The first one is about exceptional accessibility. So when we move from on-prem to cloud, the accessibility is exceptional. Like say, we normally need a 99.99% of uptime for my application. Right. So when I say cloud normally provides 6 nines, 99.9999. Whereas if it is an on-prem, or, or we are hosting it, there can be only a 97 to 99% of, uptime in our servers, in our data centers, local data centers. Whereas cloud supports this 6 nines basically, because they have a multiple regions in the backend. If a region, the entire region went down, our applications are hosted in multiple regions, like say, one region, like say one data center in Mumbai and the other data center in Hong Kong. Okay. So if Mumbai server went down, my Hong Kong server is still there. So all the traffic will move towards Hong Kong, and then, the application will be up and running there. So this is how the 99.9999 will be available for all our applications. Improved security. As I mentioned before, the security layers here, as I said, there are 4 A's basically. The first one is authentication. Whenever you log into the system, or, the server's environment, you need to have an authentication where with a username and password, and then followed by authorization. Second A, authorization. Did you have the, access to this particular application or not? Authorization to this particular application or not? Right. And then followed by access controls. So do you have access to this particular item within this application or not? And then followed by auditing. Okay. So if everything is done successfully, every step, whatever you are performing there, needs to be logged in the backend, and it's auditable later. Right. So we have a 4 A's, like say, authentication, authorization, access controls, and auditing. So there is an improved security there. And we do have a compliances on cloud. Like say if my application is a healthcare application, so I am developing a healthcare application for one of health organization, but they ask me, do you have a HIPAA compliance in for your application? So instead of getting HIPAA compliance for my infrastructure or my for application, if I can go to cloud and say ask AWS, this application is a HIPAA compliance or GDPR compliant, so then we can get such nodes or servers or services from cloud which are already covering those compliances basically. So that's another security level. And data at motion is encrypted, data at rest is encrypted, everything is again encrypted. All the keys are owner keys, not the provider keys. Provider here is a cloud provider. Owner is the end user who are deploying the application there. So the keys will be with us, the encryption keys. The data can be only decrypted by us if we pass the keys. Even the cloud provider can't see the data there. Okay, that kind of a security is implemented in cloud. And greater scalability. So there is no limitations. Like if you need to start with a one node and you just want to scale it to 150 nodes, when I say node, it is a server basically. Okay, so start with one server with a minimal configuration for my POC, and if it is working fine, I just want to use the same as my production server. We normally don't, but just I'm saying, and I just want to scale it based on my load. It can go up to 150 nodes or 200 nodes also seamlessly, right? We can create a group by. Now I'll talk about that AWS group servers and all, right? Scalability, swiftness, and dependability. So there, if something goes wrong in my deployment, okay, I deployed my application, and if something goes wrong and I just want to roll back immediately, right? So if I am deploying it on cloud, and if I'm deploying my application, I can simply roll back my application to my previous version by using automation tools. A swift, a reverse I can do. There is no HITL, human in the loop is not there. Dependability is not there, right? So enhanced cost effectiveness, we just discussed it about. So this is a pay as you go mode. You pay only for the services or the servers which you used for the time. Okay, like say I used on a monthly only 10 hours or 10 hours application it is, and rest of the time my servers are shut down. You will be paying only for the 10 hours, and you'll be paying for the storage where your data is residing in cloud. That's a very minimal cost there. Okay, enhanced cost. So possibilities for automation. So we have a multiple automation services on cloud, like say starting from your DevOps, MLOps, LLMOps, large language model operations, DevOps. Okay, similarly like MLOps, machine learning operations, where we can automate the entire process. Don't worry, what is MLOps, LLMOps, if you're not aware of, I'll be more talking about them in my upcoming slides. And also we have a separate session later, as I said. Okay, well, I'll be deep diving into MLOps there, right? With that, I just want to again mention the core pillars of digital transformations. So the web applications, the mobile solutions, artificial intelligence, AI, cloud engineering. These are the four pillars of digital transformations. When I say web applications, all your applications which are hosted on cloud, web applications like any retail or healthcare applications which are there on cloud. Mobile solutions, when I say mobile solutions, you can consider that as a mobile apps, okay, which is installed in your mobile, but the servers are on cloud in the backend. Or like say, for example, your Google Authenticator is a mobile solution. Your, what we call Microsoft Authenticator, which sends an OTP. So the security is taken care by your mobile applications there, yeah, mobile solutions. Instead of sending an OTP or a dual authentication to your email, it is sending to your mobile solution tools, like authenticator tools, OTPs basically. So mobile solutions. And cloud engineering. So when I say cloud engineering, it's not about implementing, it's all about how we engineer the process, the flow, the pipelines on cloud. So starting from your data coming into the cloud, like say, your data is transactional data, which is regularly coming from your customers to your traditional database. From there, how we get that data to your cloud. When I say cloud here, your data lake, or your storage account on your cloud. How you collect the data, the ETL process, extracting the data, the transforming the data, and then loading that data into your data lakes. How do we engineer that? And how do we do our transformations on our data? So this is all cloud engineering basically. So within that, you will be getting AI engineering or data engineering, cloud engineering. All these are part of these digital transformations there, right? So these are the main pillars basically. Now, before getting in to cloud details, I just want to talk about a few case studies, real world examples where you may be knowing them, but the details in the backend you may not be aware of. Like say, for example, Netflix. Okay, so Netflix scalable AI recommendation infrastructure, which they planned and implemented. So Netflix uses multi-cloud and microservices architecture. Don't worry at this point, multi-cloud, microservices, both I'll be talking in my upcoming slides. But upfront, I just want to let you know what we are talking about, where this multi-cloud is useful, where these microservices are useful when we are talking about those particular topics. So before that, you can understand here, oh, these guys are using this already, right? So Netflix is using these to serve AI-driven recommendations to 200 plus million users. When scaling their model inference for personalized feeds, they faced a latency bottlenecks. They solved it by using AWS auto scaling groups. This is what, when I say AWS auto scale, it starts with the 2 nodes, say, for example, and based on the load, it can scale up to 20 nodes or 50 nodes. And those can be grouped by, again. And containerized model inference, I'll be talking about that now, with GPU acceleration. This is what Netflix is used. Now, let me come back. Let me explain this. What exactly this is? What is Netflix is doing basically in the backend? What they're solving in the backend? Okay, so when you are using Netflix in your mobile or maybe in your screens or displays or TVs, the app is running in the backend, and you may also see a recommendation for you as a you watched a action movies for the last 10 days, and or the previous movie, immediate previous movie, you watched an action movie, and the suggestions, the recommendations for you will be coming like, you watched this movie because, sorry, you may like this movie because you watched a similar kind of a movie yesterday evening, right? A recommendation engine will be running in the backend and will be giving you a suggestions what kind of a movies or what kind of a web series you may like, right? And mostly you will be liking them, of course, because the system knows that you are liking these kind of videos. So this is a recommendation engine which is running in the backend. But the problem what they faced previously is these recommendation engine, like say you watched a movie now, the feed in the backend needs to be given to the cloud servers, which are at a different location. Okay, like say the cloud servers are in US, North America, basically. Let's say, okay, so the feed from India needs to be taken and sent to the cloud, and then cloud needs to understand user preferences and come up with a recommendation, and that needs to be pushed back to the end users mobile or to the application in the TV, right? And then this recommendation will be displayed where there is a latency. Like today I watched a movie, I'll be getting a recommendation maybe tomorrow or a day after tomorrow, because the engine is running in the backend on a batch process where there is a huge data they can't run in a real time. That's what the problem they are facing at that time, right? I'll let me allow Chandrasekhar 2 more minutes. I'll complete and then take your question. So this is what they are facing. So how did they solve it? So they group by these service, the servers, and then they started regional servers basically. Okay, instead of running them at a centralized location, they started regional deployments. That's what I'm talking about, CDNs. So their content and also their AI applications also moved to regional. If I am watching Netflix in India, in Hyderabad, so I may be having a nearby server which is sitting in a near data center in Hyderabad or maybe nearby in Mumbai, and my data is regional data. which is sending to my application, or the Netflix server, which is sitting regional, and implement, and run the AI model there, get the recommendation, and then share with me, which is very fast there. And these are again auto scaling groups. If many, like say, a movie released and into the OTT, and people started watching it immediately, so what happens, the load on the server will be increased so immediately, and in normal times the server load will be a bit low there. So to auto scale, they started going with AWS auto scaling groups. So these groups are in regional data centers where they grow based on the load, and then come down based on the load again. So that's what they implemented. And they also implemented edge caching and edge caching there. When I say edge caching, the data, the metadata, whatever collecting from the user, will be stored in edge systems and then processed there itself. Edge compute is I'll talk about edge compute, process it nearby to the data generators and give the solution there itself, right? So that's how they solved this particular latency problem in Netflix by using AWS auto scaling groups, containerized model inference with a GPU servers, GPU accelerations, and deploying them regionally with the edge caching, right? Now, I'll take questions now. Let me see. Yeah, Srinivasan, please. Chandrasekhar Srinivasan.
Sir, initially you mentioned that, in Netflix, when a user is watching a certain set of movies, right? The backend you said has to send the details to cloud to get the next set of recommendations, right? So isn't the backend also sitting in the cloud, or where is the backend sitting? When you mentioned that, I was just trying to understand, is it on-prem or is it in cloud, or how is it happening there?
Right. Initially, even now it is in cloud. Okay. Backend, when I say everything is in cloud, initially they are sitting in a centralized data centers. Like say, the Netflix servers are sitting in US data center in Ohio. Okay. So all the application related content and all the application related, AI models are sitting in, Ohio data center. But now those content servers and also the AI servers move to regional data centers which are near to me. If I am accessing in India, there may be a 3 or 4 data centers within India. So whichever is near to me, my data will be coming from near my data center. If I'm in Hyderabad, I have a data center in Hyderabad. So the data will be, that's called a CDN, basically content delivery network. My data will be coming from my local, nearby data center. This is what a regional, deployments I talked about. Yeah.
Got it, sir. Sir, and also, sir, just one, just one follow-up there is, in our last session, the concept of edge was explained, edge computing was explained as part of the IoT a little bit. So when you're talking about Netflix kind of application, okay, the nearest physical equipment in terms of an edge is a television, okay, and it's coming from a different manufacturer, which is, and the manufacturer may or may not have infra support for the edge computing, right? So it depends. So how does that play out, sir?
Right. Like say, for example, it can be a display or a TV, or it can be a mobile. Okay, both are same for app, because the app is installed in TV or the app is installed in your mobile. Okay, Netflix case. So every edge device will have some compute power. So your TV also will have a compute power. Like a small memory and also a CPU in it. Similarly, you also have a compute power in your mobile also. That's where your inference model, that very tiny AI model will come and sit on your app in the backend in your mobile, and will do a small jobs, not a big jobs, a tiny jobs which will be more useful for the end user immediately. That kind of a small jobs will be executed at the edge computing and then take the decisions there itself. Right?
Thank you, sir.
Right. Yeah, Prince, the way, please.
Sir, you mentioned there is a recommendation happens, and this recommendation is actually the outcome of what I have seen, right? Or what kind of content I'm consuming on my devices. So, as you just mentioned that earlier, the recommendation was coming very late because my data center was centralized and it was very far from my actual location. So, this recommendation part, right? how that was happening. Is that a program or is that any application? How it actually deciding that okay, these are the factors that I need to pick up to recommend it the second movie, or maybe because first movie it may not be able to recommend because my data is not available, but in second time it is picking up some data. So what is that program? I'm still a bit confused about it. That what is that program which is doing it?
Right. This is a ML model basically in the backend. We call it as a recommendation engine. Okay. Where it reads all your previous historical parameters, like, what kind of movies, at what time, at which IP address this particular user profile is having, all that information will be collected. And then based on that data, it will suggest you the new things. You know what? It not only read your data and suggest based on your data, it also reads the other people's data. Like, say for example, you watched a Spider-Man movie today, and it will suggest you such movies, that such hero movies to you. But at the same time, it will also see people who watched Spider-Man previously, they what kind of movies they watched later after watching Spider-Man. That also will be taken, and then, based on your data, it will, do a processing in the backend, and it will come up with an insights which is nothing but a recommendation for you. And this is what happened in the backend. This is a small piece of a recommendation engine model, AI model, which is running in the backend.
Okay, so following to this question again. So because, for example, if I'm picking up, let's suppose I'm picking a kind of application which is hosted on the cloud, and picking up all the details. For example, I'm in a bank, and I'm doing some activities which are related to my business, because here in your first example you mentioned that it is picking up all the details, my IP address, my likings, and similarly it is aligning my likings with the other guys as well, because somewhere it is trying to find out whether I'm into a particular age group or not,
Right.
because based on that it is recommending me some product, right? Or maybe application, or maybe a movie. So for
Right.
example, because here I see it is actually acquiring all those details which are very 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 important for me, and these details are very personal to me as well.
Correct.
So because it is actually bringing my IP address, picking up my IP address, my age, my something. So do you think if I'm into a bank where the regulations are very difficult, very very difficult to bypass, so in that case, if such applications or such AI models or maybe ML models are picking up these details and putting it into a server where I don't have a control, so how the governance will work, how the security I will ensure that my data is secure?
Right, right. So, two things here. The first thing is about if we are, these are the, policies or consents which we sign when we logging into Netflix or when we logging into in our banking applications. So at front, they'll give all the policies. We just need to go through them, where we normally don't, and then we just scroll, and then we used to say I agree, and then click on it. So that's where we give our consent, saying that, okay, we are okay to collect all our data and then keep it with you. So they'll say that your data is not going to be shared with anyone. Your data is not going to be used for any other purpose. But still, we are signing that consent when we are logging into this application and the data is collected. So it is upfront when you install your application, this has happened. Now, the second part, when you are working with a bank, like say, you have a bank application or a net banking application installed in your mobile, even that is collecting the data because of a positive side there. So if you are doing some transaction in India, and suddenly within a 2 or 3 seconds and another transaction happened in in another country, that is a fake transaction. That is a that should be identified as a wrong transaction there, right? So how can it be done without knowing your IP address, or without knowing your where you are locating, or which browser you are using, from which mobile it is accessing? All these details are captured by any application in the backend. Even like say for example, you open a website, not even login, you just open some website. That website server will collect your IP address, your browser, is it like Chrome or a Firefox, which version of it is, your IP address, and everything is collected from your browser to the system. And the browser is concerned for that. This is common. And the final part, you asked about the security, how secure it is. So we signed it. They also says that your data is not useful for any other purpose. It is safe with us. So we signed for that, and then we agree, and then we are moving towards using the internet. Right?
Yeah, got it, sir. So it means the consent that before acquiring any detail, there is a consent that needs to be signed by the business, and then only we allow them to have an access on my data. Okay,
Exactly.
got it.
Exactly. Even you take a chat GPT, like say, for example, when you first log into your chat GPT, it simply says, in the bottom also, it clearly mentions that AI is not 100% correct. Don't take critical business decisions based on AI. It clearly mentions that, because that is a concern which you need to understand. And if something goes wrong, you can't go back and say, I have taken a decision based on chat GPT, because chat GPT upfront, it is saying for you that, don't believe me 100%. Right?
Yes, indeed.
Right? Yeah. Thank you. Murugesan, please.
Yes, sir. Yeah. Actually, I just want to understand this. Where it is coming here. So, for example, we are talking here the inference and the AWS auto scaling. Okay, so is it any algorithm is running on this level that can help, scalable inference systems, or this AI algorithm is only running on recommendation engines?
Okay.
So, yeah.
So the recommendation engine is the application which is running on a particular group of servers in the backend, AWS auto scaling group, which is deployed in a nearby region. Okay. Now the engine in that recommendation engine is running a model. Okay. That model is not a real-time, a trained model or real-time training model. That is an inference model, which is a tiny model where it can take real-time or a near real-time decisions and give you the recommendations. So as I said before, when the recommendation engine is running in the backend, the inference model will consider or will read the data on your profile only. It won't compare that with the other profiles. As I said before, like you watched a Spider-Man movie, and it will also check with the other people who watched Spider-Man in the same region. It will also do that, but not at an inference level. It will collect the data. Inference will give you the recommendation at this point to you, which is done. And the rest of training model, this data will be sent back to centralized servers in the cloud, where the other man's data is also there. The other man who watched the Spider-Man movie, that guy's data is also there. Now the comparison between people who are watching Spider-Man, 100 people, out of them, how many watched immediately after that, a James Bond movie? Okay.
This is
So that's where how it worked. That's a training happening at a cloud data centers level, not with the inference model. The inference model is for you to give the decision, on the fly.
Understood. So, because if we are talking about leadership perspective, like your question is also in the down, like how can leaders design the scalable inference systems without over provisioning? So here in this case, if I'm the Netflix CIO, what are the decisions I would take? This is only for the decision of AWS auto scaling, or choose the edge computing, or where the leader would take a decision on this. I know the problem, yes, and the only problem is the solution of the problem could be like, okay, introduce change in infrastructure or any other thing I could use to solve this problem.
Right. So the decisions at a CIO level or at a chief data officer level will be taken only based on the data, based on the information given by the applications. Like say, for example, if they understood that there is a latency to watch a movie which is deployed in US and which is viewer is looking in India, the latency is there where there is a business loss basically, right? So there is I don't want to get the name of the application. There is a app, a local region app in, India, Telugu app. This is an OTT app where this is a very good app and there are very good movies in it. They launched it and in only in India. All the people who are watching these OTT in this particular app outside of India, they are having very latency there. So they can't stream the movies seamlessly from outside because the application is hosted in India, because that is mainly concentrating for the Indian people. For the people outside of India, they are not using that app at all because the application is very slow. Now the business impacted out of India, right? In India, they feel that, okay, I'm fine in India, I'm good, I don't want outside business. Then it is fine. The CIO will take, okay, let it be in India only. Let's not move it outside of India, because the people who are outside of India is only a 0.5%. If they are not looking into my application, still fine. I only need to give to my audience here, and the cost for me is going to be very low if I host it in my region, right? So that's how the decisions will be taken by these people. It's not like whether I do it or not, guessing or not. No, based on the data, based on the business impact, they will take the decision.
Thank you.
Yeah. Deepak, please.
Hi, sir. Just in terms of my question was on this case study with respect to Netflix. In terms of the differentiation here, like it seems like, at least on the outside, I mean, I don't understand too much of technology as far as cloud computing is concerned. At least on the outside, it seems like Netflix employed AWS auto scaling groups to kind of reduce latency and improve the efficiency overall. So in terms of the differentiation here, like AWS auto scaling is available to everyone, across companies. So what are the decisions that Netflix took differently as compared to other providers to be able to kind of, crack this? It seems that AWS, this solution is available to everyone, right? Like, so why is this just a thing that is, very different for Netflix? And,
Got it.
I'm just trying to understand, like, in terms of decisions that Netflix has to make,
Right.
is just, oh, let's go with the auto scaling, like it's already available. Like, is that the decision, or are there other
No. I'll tell you.
things that they are doing which are very, very different from like what others have not been able to crack? You
No.
get my question? I just wanted to understand how
Got it.
that.
Got it. So, these are two things which we need to understand. The first thing is about sometimes business requirements will be there, and then the solutions for them on cloud may not be available at that point. Okay. When the solution came in the cloud, immediately the business holders may take that, grab that, and then implement it, try it, and then use that. This is one way of looking into it. So previously, auto scaling groups are not there, and then when they introduced, Netflix started using them and they benefited out of it. And one case study we got it here. There are such many other case studies also. Now the other way of looking into it is based on the requirements, business requirements. Cloud providers will understand and will start experimenting with a certain organizations. Okay, cloud provider will go, AWS will go to Netflix because Netflix is an enterprise customer for AWS there, right? So they will go to AWS, Netflix, and say, okay, what are the problems you are facing currently? How can I solve them from our side? Okay, now AWS will give a solution for them, a customized solution for Netflix, which can be implemented, and Netflix will benefit out of it. And then they'll say, okay, this solved my particular problem immediately. Now see, if you Spotify here, a similar kind of a solution is there with the Google Cloud. So Google Cloud implemented a similar kind of a solution, and Spotify went to them, and then they use their data lake kind of a centralized thing, right? So it depends on the business requirement. It depends on the cloud provider will always go to the enterprises and they'll ask, okay, how can I help you? How can I get a new solution for you to the pain points currently? That's where we also do, right? Like a business guy, I may go to, like, say, I closely work with oil and gas companies. I have a almost like a 3 to 4 oil and gas customers. I go to them and then I'll ask, okay, this is what AI is currently doing in the market. I just want to understand your pain points to solve them by using AI. Now they will give me, these are the things which I'm daily doing in my daily life. But these are the some pain points. Can you solve by using AI there? So then I'll do some experiment as a POC kind of a thing. And if I solve it, then that is going to be a use case for me and a case study for others. Right? So that is how these used to be implemented. This is not something new happening in the business. It's a common practice which enterprises used to do.
Okay. So AWS is mainly solving, like once they hear the problem statement, they're taking the problem in-house. They're, just experimenting and then trying to solve the problem. But in terms of Netflix themselves, like they don't really engage in, hey, this is the way to do it, or this is the design that we need to have it. It's all AWS solving it for them as far as this latency problem and all of that is concerned.
In this particular solution, yes, you can consider like that. But normally, Netflix may facing that issue, and no cloud provider is doing that. So Netflix will start their own solution instead of going to the cloud. Right?
Okay.
They need to do that. Otherwise, their
Got it.
latency will be there. If you open your TV and open your Netflix and start clicking on a movie, if it takes like 30 seconds to 1 minute to start the movie, that there itself you feel that there may be a internet issue. First of all, you will trust
Yeah.
blame first of all your internet, local internet, not the application.
Yeah.
And then will followed by okay, this guy, my internet is very good, because my another application, what is that, my Amazon Prime is playing very well, Netflix is not playing well, so it looks like Prime is having some issue, right? So that's a drawback for the organization. So they definitely need to come up with a new solution there.
Okay, thank you, sir.
Yeah. Now, Ragini, please.
Yeah, Prof, my question is very quick. So I understand the multi-cloud, which you explained, centralized versus regional. How do I understand the microservices based on what you explained?
I didn't talk more about containerized and microservices here because I have a slides up, in the
Sure,
next.
we can take it then. Yeah.
Cool. Nice discussion. So are there any questions, or can I move to my next use case? Again, don't others who are not asking questions are listening. Don't feel that we are spending more time here. This is planned. The first 1 hour is going to be a very slow and addressing all the questions. We'll build the foundations, and then from there, it's each slide may take 2 to 3 minutes, right? So now the second problem or the second case study, which I just want to explain you here is a Tesla, okay, or any autonomous cars, okay. So Tesla processed terabytes of data from sensors and cameras using its Dozo supercomputer. So this is what they used to run or train their models after collecting the data. But the problem, they can't deploy these supercomputers or Dozo supercomputers in the car, okay? So they should be in the cloud. They'll be running all their models in the cloud by using Dozo supercomputers. But the model inference, let me minimize this. The model inference happens at the edge inside the car. I'll be more concentrating on this part now. This avoids latency and connectivity issues. So what exactly here they are solving? Now, of course, some of you mentioned about edge computing was discussed in our previous session when we are talking about IoT. Now, this is also similar kind of a thing, but let me deep dive into this edge compute here. Now, there is an autonomous car, like you can take a Tesla vehicle there, so which is going on road. Now, suddenly an object appeared. So for car, everything is an object. For us, it can be a human, it can be an animal, it can be a some device, but for car, it's an object for it. So if some object immediately appeared in front of it, so the sensors which are collecting data, those need to collect the data. Like there is an object in front of me, and that data needs to be collected, and the data if sent to the cloud, okay, by using internet within the car. There is an internet, let's say. Now the data needs to be collected and sent to the cloud, and the cloud need to process that particular data, the parameters which are came from so ABC car, and process that, and immediately the decision needs to be sent to the car saying that, oh, there is an object, it's a dog actually, you need to apply the brake immediately. Now the decision is sent to the car. Now the car started applying the brake, right? how much time it may take if this is the case, right? So let's take the internet is very fast. The Tesla servers are very fast on cloud. The sensors which are collecting in the car are also super sensors which collected data and sent. Still, it may take at least 30 seconds to 1 minute to get the decision back, right? By that time, the car would have been already hit that object, the dog, right? The collision would be already happened there. So which is not correct, right? So the decision should not be taken by the cloud systems in these cases, right? The decision should be taken at the edge level. Edge here is nothing but your car, okay? Your car need to take a decision. How can it take a decision? The latency should not be there. So there is a latency to get the decision from a cloud server, which is not acceptable at all. So the car need to take the decision. Now, what is the process? Now, the sensors, whatever they're collecting the data, these are called data readers or data generators, basically. Okay. Once the data is collected, the data will be immediately sent to the compute power which is sitting within the car. Okay. The compute power sitting, which is sitting in the car is nothing but a edge compute. That is called edge compute. The edge compute will be always very nearer to the data generators, very nearer to the data readers, very nearer to the decision makers. Okay, that's where we call it as an edge compute. And you know what? I can't go and place my Dozo supercomputer in a car, which is not possible, right? So I need to have a very tiny server, a very tiny compute power, and which can also take a decision there. How the decision can be taken? AI model needs to be there, understand the data, read the data, process the data, and the decision needs to be sent to the car. So there needs to be a AI model which is running on the compute at the edge compute, basically on the edge compute. So now what the edge compute should be, right? Edge compute with a tiny memory, tiny CPU, and tiny AI model, which can, that's where your inference model comes into the picture. Your inference model is a tiny model which will not train or which won't do anything else. It will have a very small parameters, where it can take a decision there, where it can also run on a small compute power. Okay, very less compute power. I'm sorry. So the tiny model which is sitting in the car will take a decision on based on the parameters, and the brake will be applied immediately within fraction of seconds, right? That is how your edge compute will work. That is how your edge compute will take a decision. Now, once your vehicle reached, the Tesla came back to the home, it's connected to the internet, home internet, or it has the Wi-Fi internally, so it connected to the cloud. Batch data transfer will happen. Once the car reached to your home, like say after 8:30, you schedule it, or the compute in the car will schedule it. After 8:30, between morning 8:30, the data which is sitting, the sensor collected data which is sitting in your car will be transformed or transmitted to the cloud. Now the data which is moved to the cloud will be processed, and when I say processed, will be processed, and the models which are readily available there will be trained on the data which is generated freshly, by using Dozo supercomputers on cloud. Now the models which are trained, the fresh models which are trained, the model, tiny model, again will come back to your car and deployed in your edge compute. Okay, this is what the pipeline which happens in the backend, so that your compute which is sitting in the car, Tesla car, will be always updated with a very tiny model, inference model, which comes on a daily basis, or the scheduled way, whatever the Tesla scheduled way, it comes in, sits in your car, and then it take the decision there itself. It won't send the data to cloud. Yeah, does that make sense? Looks like there are a few questions. Yeah, great, friends. Thank you. So Deepak, please go ahead.
Yeah. So in terms of like the time it takes to make that decision, you said it's there in the car. The edge compute is stored in the car, right? So that's completely reduces the latency. So is all the intelligence with respect to, hey, this is a moving object, and the decision, like the whatever the supercomputer is going to suggest, is it stored completely in that edge compute in that small compute power?
Yes,
And then only data collection at the background is improving the model, like you said, right? Like that happens later. So
correct,
if, like for example, if cloud is down on a in that instant, it doesn't really matter, and the decision is still made, right?
correct. Correct, you're
Okay.
right. The decision is taken, at the edge compute level. You will be having a small, GPUs within the car itself. It's, a tiny GPUs will be there where your deep learning models will execute on that GPU in the car itself, which is in a small, size of your your hand size it is, right? Which will take the decision there itself,
Okay. Thank you, sir.
right? Yeah. Yeah, Prince, please.
Okay, so in case our car has decided, or the mechanism to identify that what object it is, it has applied the final decision whether it has to put the brakes or it has to reduce the speed. So in case if there is a completely new object comes which never been trained, the AI model that already pre-installed, so in that case how it actually going to be trained? So whether the information collected by the car now, once it will reach to the destination, as you just mentioned, that it will again send the whole data that whatever it has procured this time, and it will be sent back to the cloud, and then it will again get trained and come back to the machine again, to my car again. So this object, but at the time I need to take a decision when a new object identified which my model never seen in the past. So what decision it will decide, what decision it will take?
Right. So whenever you create an application, by default, you will create some known selections or on options when you create a drop down. At the end of the drop down, you'll create a others. Okay. Like say, for example, if you want to select a drop down for your education, there will be a BSc Computer Science, MCA, BE, or MBA or MSc or MCA. Kind of a multiple options are there, but there are many other streams which you are not aware of and you don't want to add them here. You'll simply say others, right? Similarly, even in these such cases, there will be a model. The model will be trained on most of the objects, but if the objects is not there, it will classify it under a other object, and based on that, like say a moving object or a stable object, they will be classified like that, and based on that they will take a decision at that point.
Okay, so you mean to say that all the other objects, based on few of the criteria or based on the few features out of it, it will decide that whatever maybe a generic decision needs to be
Right.
taken.
Right.
Okay, okay, got it.
A generic decision, like as I said, is it a moving object or it is a stable not moving object? So how it can be a living thing or a non-living thing?
Okay, got
If
it.
I can decide, if I can classify like that, a living thing should be immediately brake applied. A non-living thing, do I need to take a immediate left and then move out of it, or do I need to see the left side vehicles if there are any coming, let me look into it and then take a decision and then move left and then go forward? That kind of a generic decisions will be there.
Okay. Okay.
And again, to answer your question, there may be a corner cases where
Yes.
the system may not, supply the decision, and something will happen.
Yes, that's why all AI models, mention that they are not 100% accurate.
Exactly. Exactly.
Yeah.
So the corner cases,
Yeah.
we may not, identify upfront because we are identifying all the cases, but every time we may not know what happens, upfront, right? So those are corner
Perfect.
cases.
Perfect.
Yeah. Badr, please.
Yes, sir. Just to conclude, what I understand that the edge computing is going to take the critical decision, and the cloud computing will do the enhancement of the system intelligence, right? This is what I understand, right?
Correct.
Okay, thank you. That's all.
Okay.
Thank you.
So, thank you. Coming back, the case studies we discussed up to now about scalability and performance bottlenecks. Now, similarly, I just also want to talk about data storage and management. Okay. So here the case studies I'm talking about Spotify here. So previously, Spotify has all their user profiles located at a regional level, not at a centralized level there. Okay, in this case, they have a centralized location, they moved to regional. But in this case, they have a regional, they moved to centralized, because this is a data, this is an application, two different things. Data we need to always have at a centralized location. Applications we can move them to regional to supply a near real-time solutions to the end users. Okay, that's what the difference is. So here, Spotify moved from multiple data silos to a centralized data lake on Google Cloud. Don't worry about what is data lake. I'll come to that later. Data lake on Google Cloud. Google Cloud is one of the cloud providers right now, like say Amazon, AWS, Azure from Microsoft, Google Cloud from GCP from Google. Okay, so they moved to Google Cloud and they used a BigQuery and Dataflow, the tools basically. Don't worry about them. Those are engineering tools. BigQuery and Dataflow in the backend, and they solve this unified user behavior, playlists, content metadata, all enable faster ML training for personalized recommendations. Because previously what they have, the same way, here there is a recommendation engine, we are getting problem because it is a centralized, the application is centralized. Here the recommendation engine, the data is at regional and they move to centralized. Because if a model is training on a data, in this case, if you can see, the model need to be trained in Mumbai, India region, in Hyderabad, India region, Delhi, India region, and collect the data and centralize this ML model. And again, if someone is accessing this Spotify from outside of India or from US, then again the model need to run on their data at their data center on their data. So the model is running multiple times at multiple locations on multiple data places and then collecting them and then aggregating the model insights, which is taking huge time and latency. What they have done, they collected all the user behavioral data. Here it is a user behavioral data, not the content, basically, not the the audiobooks, not the audiobooks, basically. The user behavioral data, which is profile content. They collected that data, placed at a centralized location. They started running their AI model on the centralized data. Now they got a recommendation engine there. That recommendation engine is sending the data to the apps, which they reduce the model training time by 60% of their time and also the cost. So data centralized is very important with this example, Spotify example. Okay. Now, similarly, I'm going to another example here, JP Morgan Chase. So they implemented data lineage, versioning, and governance policies. Okay, I'm talking about here again, governance policies across petabytes of transactions in a hybrid data lakehouse. Okay, it ensured traceability and compliance for financial AI models. Now, what exactly they have done? Coming back, I'll be talking about two things again here, which also will be covered in my upcoming slides. Hybrid data lakehouse. Because JP Morgan is a bank, the transactional data of their customers should not be moved to cloud as per regulations, country regulations. The data should be on their on-prem servers, JP Morgan servers, basically. They should not be moved to the cloud. Okay. So with that reason, because they have their GDPR compliance issues there, regulations, bank regulations are there, they can't move their data to the cloud. So what they have done, so they built a hybrid data lake house. Data lake house is something like your data lake followed by your data engineering layers followed by your decision layers. So end to end is called as a data lake house. Okay, so they build a hybrid data lake house. So the data is sitting on prem and the application is sitting, the AI model is sitting on cloud. Now by using the AI cloud applications or AI models, the data is not moving to cloud at all. The AI model is reading the data from here and then building the AI model. So the training is happening by using two different regions or two different networks or two different clouds, basically. One is a private cloud, the other one is a public cloud. So that is how they are doing. So these kind of implementation is called hybrid data lakehouse. Something is in-house, the other thing is in public cloud. So merging these two and implementing them is called hybrid data lakehouse. And this is possible by using a tool called, or by using a concept called sovereign implementation in cloud. Okay, sovereign implementation in cloud, right? So I'll be coming back in detail about that particular terminology, technology in our upcoming sessions. But at this point, you can understand there is a technology where we can read the data which is in on-prem and then can train the model on cloud. Okay, so why do I need a more training model on cloud? I can run it in the on-prem, right? But the model should be on cloud because I need a scalability of my servers there. To train my model, I need a huge GPUs, a compute power, which I need to procure if I just want to run it on-prem, which is not possible, which can be possible on cloud, right? That's what it is doing here, hybrid implementation. Yes. Jansi Rani, please. Jansi Rani, sorry. You are in mute if you are asking a question, Jansi.
Okay. Sorry. The question is very simple. So regarding this JP Morgan cases, like a hybrid data lake house. So we are reading the data from the private cloud. Someone need to send this data to the public cloud or to do this, AI model. So is there any tools they are using it? You
Correct. That's
mentioned
what I
it.
said.
Yeah.
The AWS sovereign technologies are there. I'll be more talking about them
Okay.
going forward.
Okay.
If you want, I'll also. What is this? Yeah. If you want,
Yeah.
I can also share you, the documents which I prepared. Let me quickly share that with you.
So maybe I would also tell why we are asking this context. So I'm from SAP. So in SAP, we have something like a business data cloud.
Right.
So yeah, I don't know about this competitive product from AWS. So that's what I'm little interested.
Okay.
But yeah.
So this is what I'm talking about. Confidential
Okay.
and sovereign cloud, emerging trend in cloud computing in 2025. This came in 2025, basically. Okay. So why this trend matters? So your confidential cloud focuses on data protection during processing, encryption even in use. This is a simple concept. I'll be more talking about in my upcoming sessions, but at a very high level, I'll just introduce this. We know if the data is at rest, it is encrypted. If the data is at motion, it is encrypted. So in cloud, the data is at motion, encrypted. The data is at rest, is encrypted. Fine. But if the data is processing, like say the data is reading by the memory. Now the data is in memory, which is already decrypted. If I can crack my memory, crack my compute memory, okay, my the processing system's memory, the data there, it is a decrypted data. I can see all the transactions which are there in memory. You got my point where I'm coming from?
Yeah.
Right? If the data is in network moving, it is encrypted. You can't decrypt there. No, because you don't have a decryption keys there. If the data is at rest in storage on cloud, you can't go and encrypt it. You can't go and decrypt it because it is already, data at rest is encrypted. But there is an application which is reading your data. So when it is reading or when it is processing your data, the data need to be read from a storage, get it to the CPU by using memory. There it needs to be decrypted and the data needs to be understand there, and then only the actual solution or the actual output will come, because the application need to read your data. That's where your in memory is decrypted. If the hacker can log into your application, crack your application and expanded your memory and then looked into that, like, okay, here the data is open, the data is decrypted here, I can read the data, then your data is leaked, right?
True.
That's where we normally won't believe cloud, to move our transactional data to cloud. But thanks to the cloud providers, they came up with a new concept called sovereign cloud. Okay, confidential sovereign cloud. Even your data at processing, it is still encrypted. Encryption even in use. Even the memory or even AWS server who is holding it, the IT guy who is running your entire application on cloud, AWS IT guy, they can't even read your data when it is processing, because the data is processing even it is in an encrypted format only, right? So that is a new
Yeah.
technology came in recently. So that's where your encryption, everything, even in use. Okay, that's called local data, local rules. Everything will have a local thing like GDPR, EUVI Act, India DPDP, HIPAA compliance. All these will get into that. I'll be more talking about this later. I don't want to
Yeah.
get into
Sure.
here. Yeah,
Thank you.
thank you. Does that make sense? Are there any? Yeah, but you have a question. Please go ahead again.
Yes, sir, question about the Spotify case. What I can see that is the data all centralized. I don't know. It's all in one place, but isn't it too risky to put all the data in one place in case without a backup? I don't know. In case of the system is down or the system.
Right.
Yeah.
I'll let you know. So when I say data at centralized, previously the data at A is not in a B location. So the AI model needs to execute on location A and also in the location B. That is what the problem we are facing. Now, when I say the data is centralized, came to at a C location, where like A data, B data, D, E, F, all the regions data came into a C location, and the data is centralized. When I say that the data is centralized, but it also have a redundancy in the backend. So there will be another region which is considered as a backup, or maybe a disaster recovery unit or disaster recovery a region for that. So if something goes wrong with the master one, the second one will always come up and then act as a active way. So it is an active and passive, or active or active and redundancy. That mechanism will always be there. Yeah. Cool. Looks like there are a couple of questions. AWS owns the domain knowledge and proposes a new solutions to Netflix. Okay, this is okay, long back. Mirror. Okay. Yeah, Peter, mirror. Yes, it's always there will be a mirror concept. Yes. Right. Now, coming back. Cool. Let me put the screen. Let me see the time.
Sir, just one question, right? You're talking about the infrastructure being cloud, right? And the applications can be on-prem or on cloud, and the data may be sitting on cloud, right? So the elasticity that you have on for the data, right? The applications are designed sometimes to manage finite amount of data, right? When you design an application. So is there a benefit of designing an application on cloud versus on-prem so that the enterprise can maximize the benefit of the cloud offering?
Right. There are very nice questions. So let me give my example, my experience, and with after that I'll take a break of 5 minutes break, and then we'll come back. So in our previous organization, we used to conduct these corporate trainings. Okay. So in the I'm not talking I'm talking about almost like a 7-8 years back. Okay. So we need to provide a big data applications, like say, I don't know how many of you know, there is a concept called distributed computing, Hadoop. Don't worry about all these things. I'm just telling the terminology for now. Okay, remember that. So there is a technology called big data, which is a Hadoop, and we need to give a hands-on experience to all our participants on Hadoop. Okay, so if I deploy these Hadoop application on cloud, and if I just want to give 24/7, 365 days access to my participants, there are 60 members in each corporate batch, and there are 6 batches parallelly running. Okay, approximately 300 people are using that. Now, if I just want to give this 24/7, 360 days on cloud, the cost is going to be for me like a blasting, because these are distributed computing where there is a GPU involved in the backend, huge costly servers basically. Okay, so this should be always 24/7 running. Maybe the user using it or not doesn't matter. Those need to be on, up and running at that point. So for that, cloud is not a solution. Cloud is not a good solution, basically. What we have done at that time, we invested a capex there, approximately 1 million, and then we got, huge giant servers on-prem, and then we hosted our applications, these big data applications in-house. And then, there is no internet other than the internet cost and AC cost. We don't have any other cost involved there. Okay, we are giving a 24 by 7, 365 days access to all our participants, and we just started marketing. No other institute is providing you a big data infrastructure 24 by 7 access. So we got a marketing, we use that as a marketing tool there, right? And we didn't see that as a drawback, because if I go to the cloud, with the cost which I spent to procure the servers will be utilized in 1 month, and rest of the 11 months I'm going to extra amount which I'm going to do that. With that 1 month of cost, I procured the servers and I implemented it, and it took a 2 months of a time. From there, it's seamless access to my all the participants, right? So one example I'm just giving to you. There are such cases.
Got it, sir. Thank you, sir.
Right. Mary, reference to JP Morgan, did I hear you say that using sovereign cloud technology, data is processed when it is at rest in memory and at the state it is encrypted? I didn't say that JP Morgan is using it. There are technologies to do that, is what I say. JP Morgan has its own, hybrid cloud, not a, fully on cloud. That's a hybrid cloud. Data is sitting on-prem only. The application, the models are, on a cloud. Yeah, Manny, you can unmute yourself and you can ask if you have a question there. Got it. Great. So there are, I discussed about a new technology, which is a, sovereign technology, which recently came in 2025, where the data can be encrypted still when it is processing, is what I told. There is a new technology, but I didn't say JP Morgan used it, because JP Morgan's is a hybrid way, which is a traditional process which all other banks also follow. Yeah. Okay. With that, 8-5 for me here, 8-4. Let us take a 5-minute break and then come back. Chandrasekhar, I can see still your hand raised. Is there still you have a question or? Okay. Fine. We'll come back in another 5 minutes and then continue. Thank you. Okay, I'm back. Please let me know if we can start. A quick thumbs up or yes or no will help me to start or hold.
Yeah, sure.
Yeah, thank you.
Yeah, you can start. Thank you.
Yep. Okay, so there is a question from Sam for JP Morgan. As organizations scale AI across multiple functions internationally, okay, internationally, globally, how should leaders balance speed to value against the need for data lineage and governance? Especially when governance controls can slow the experimentation, of course. How they govern data across nations. Great. Okay. So, to be honest, how JP Morgan handles it, I didn't see any of their solution where they published online. But if this is a regular question, like how what can be a solution for these kind of implementations, then the data will be centralized, of course, but the users who are working on their particular applications, they can move their data to their own data lake, okay? Or they can hold the data in the same data lake, and they can read that data to their application, like say, another tool like data breaks, or can be any other Google BigQuery kind of a tools. They can read that data and they can build their application separately for their experiment purpose. So the data need not be on a separate server or in a separate region for that particular organization unit within the organization. Not required. But as you said, the governance will definitely slow down if we are working on a big scale such AI implementations. Now, coming back again, one more thing is also there. These AI implementations at these enterprises, this is not a positive thing. At the same time, also not a negative also. Okay, we need to see the both pros and cons in this case. So the organizations, the enterprises are not building AI capabilities across the organization in a single as a single solution. No, they used to build these AI solutions at a unit level or a business. I mean, when I say unit, business unit level, like say, credit card section, a separate AI implementation. Transactional data, a separate AI implementation. Support services, a separate AI services. So that's how they divided it, and then they implemented it so that there won't be any dependency on other teams there. That's how normally they used to handle. As I said, pros and cons are there, of course, in both the cases. Yeah. Hope I addressed your question, Sam. Great. Thank you. Let me move on. Okay, so let us get into from here. I'll be moving a bit fast because we have a ground, a foundations established by now with all the topics whatever we discussed. So from here I'll be moving a bit fast, right? So cloud computing, the foundation. Fine. Let me put the cloud computing in a layman language first, where everyone can understand it. So if I am accessing any application or anything for that matter over the internet, okay, which means I am using cloud. Okay, if I am accessing anything over the internet, then which means I am accessing cloud basically, right? Now, if I am accessing a compute power, a storage, a memory, or a network services over the internet, that is called cloud computing. Okay, so that's where these two are mapped. So if I'm accessing an application by using my browser, then I'm accessing the cloud application. Okay, but if I'm accessing a compute power over the internet, which means I'm not using my laptop for my application purpose. Okay, I'm using over the internet to develop my application, some other compute which is not in my laptop, which is not utilized in my laptop, then that is called cloud compute. Okay, I hope I addressed it. Everyone can easily understand in this way. If I can access memory, storage, compute power over the internet, which is called cloud compute. Simple. Now,
sir, can you just give an example of the second point where we are not using the local computing?
Great. I'll address that. So, for example, every one of us have our own laptops now, right? So if there is a MS Office installed in my laptop, MS Office, which is an Excel, PowerPoint, Outlook installed in my laptop, and I'm using that, even if I remove my network cable or switch off my Wi-Fi device, and I can still use that, which is in my compute, So my Excel is using my CPU, my Excel is using my memory, my storage, which is in my laptop, right? So this is a on-prem. This is not a cloud. But the same Excel, the same PPT, if I am accessing through browser, which is Office 365, okay, that is called a cloud compute. Got it?
Yes, sir. This is clear.
Yeah. Right. Prince, please.
So, sir, in previous classes, there was an application was mentioned. It's a Google Colab, that is, or Google Drives. These are also a part of cloud, is it?
Yes. Okay. Kubernetes is a tool which can be executed or implemented on cloud or on-prem also. Even I can do that in my laptop also. Okay.
So Google Colab, where I think last
right.
Google Colab is
So
also part of that, right?
Exactly. I will address that now. Say, for example, AI services, if you see here, AI services are, the data platforms. So if I am accessing my data, which is in my OneDrive, okay, which is a data platform where my data is sitting in cloud, okay, on-demand access. You access your data, you delete your file there, you're not charged for it. If you are saving your file, you're charging for it, right? Similarly, Google Drive, right? So those are data platforms, again, cloud compute. AI services. Now, like say, for example, you are running ML model on Google Colab. Okay. So Google Colab, you are accessing over the internet. It is not on your laptop. If you install Anaconda or a Jupyter notebook in your laptop and you are running your AI model in your laptop, even without internet, then it is on-prem or in your laptop, right? But if you are accessing the same thing by using browser through internet or over the internet, then it is on cloud, which is Google Colab for you in that case. Yeah, does that make sense? Nice. Now, on demand. So I explained what is cloud compute. So on demand access to compute, storage, data platforms, AI services. When I say AI services again here, you can consider, like say Azure AI Foundry is a AI services. So previously we used to, develop our own machine learning model in-house and train that machine learning model on our data and get the inference model, use it on-prem. This is how we used to do previously. But now, no need to build a model. No need to, train the model also. The models are readily available on the internet where you just need to select, like say your Hugging Face, okay, or your Azure AI Foundry or your AWS Bedrock. These are the services which are AI services which are readily available in the internet. You log into your cloud provider, select one of the model, let's say your recommendation engine or your deep learning model, convolutional neural networks, let's say, for example, select it, and then you can use it on the cloud itself. You no need to build it. It is by default trained on certain data, and no need to train on a particular data also. You can directly use it. Like say, for example, I need to extract data from a PDF file, which is in a PDF format. So what I need to do, data extraction part basically, right? So if a model is already trained on extracting data of a PDF format, which is directly usable for you on cloud. Now, let me deep dive even into that. My PDF is a invoice. I need to extract data from my PDF file, which is in an invoice format. Now the model is already trained on invoices previously. You can go and select the model which is already trained on invoices and use it. No need to train it for again on your invoices. Not required to extract the data. Similarly, a white papers. Similarly, the Wikipedia. So the models are already trained to extract data from Wikipedia. You go and select them. You use it directly, right? So that is how the AI services on cloud are on demand available for you, where your experimentation will come with very low cost. All the POCs you build on cloud directly, use them. If the success rate is there, then you can build a real time again on cloud. So POCs by default will go with the cloud, right? Rapid scaling based on your requirement. Like there is a huge data which you need to train now. You can rapidly scale it. Or there is a huge load on your server. Like as I mentioned before, Azure, sorry, Amazon's Thanksgiving Day sale. Okay, there is a heavy load on the servers on that day. So rapid scale will be there for the servers, which can be easily available. Cost efficiency. For those 3 to 4 days, you can use it and then let the servers come down again from 300 servers to 2 servers. Cost efficiency. Shift from fixed capacity to adaptive capacity. This is what cloud is giving more advantage for us, right? Deepak, please.
I just had a question, sir, on you said models are readily available. One question on context within these models. So, for example, I'm like from the fintech space.
Yeah.
So, do some of these models, when you have these models which are ready, do they have the context, or is this something that the fintech company has to work with like Azure Foundry or Bedrock to kind of enhance it? Like, how does that part of the thing work? Like, when you say it's readily usable, is it, it needs to also have the context to be able to say, oh, this financial data has to be understood in a certain way. Like,
Right.
how does it really work?
Right. So it depends on case by case. Like, if say, for example, finance data, when you say, if you're talking about a, P&L kind of data where, the model needs to understand the P&L, definitely there are existing models, okay, which are trained on P&L or invoices, like say, for example, accounting purpose, POs, purchase orders, these kind of a data models are already trained and readily available. But if you have a corner case solution which you are looking for, then in that case, there may not be available, or you need to customize the existing model for your requirement. That's how it works.
Okay. And the customization happens by working with folks in AWS, and
you can request them if there is a good business requirement, even for them, if they can take it from you to another company, then they will definitely work with you and then, solve it. But if it is a unique use case which only helps you and there is no, business for that, for AWS, they may not.
okay. So in that case, how do you kind of
we
solve?
need to we need to build our in-house team, where they can data science and data engineering team, where they can build such a small solution for us, a unique solution for us in-house.
Okay, got it. Thank you.
Right. Jansi Rani, please.
Okay, my question is very simple. Imagine like we have a data model already available. So I'm thinking in the context of academic context. So, in our India, so we have a state board and central board. So
Right.
imagine that I'm a state board and I take the initiation. So let's build the data model for all the state board books. Okay. So only for the south part of India.
Okay.
Would that data model can be also taken and uplift by the central government, or is it something like the data model is built only for the what you can say, like a south part of India, so the north part could not able to use it. So we have a security mechanism on that. So
Right. So if the parameters what you have selected to run that model for South India, if the same parameters are used for even the other part of India, the same model can be used. Okay. And the model is built, like say, for example, as you mentioned, academic part. So like say, for example, the model is developed and trained by a university. Okay, it's like say a South India JNTU university. Now that model can be placed in a marketplace where in the cloud, where the other part of India or the other outside of the India can also download that model from marketplace and use it. Where the university will be getting money by the users who are using that particular model from outside. But it depends on the parameters what you have selected, and those parameters are really useful for others also. If it is not, then they need to again retrain the model.
So we can we can build a model and then we can sell it also the other people.
Yeah,
Okay.
Of course, yes.
Okay, great.
And of course, the universities research teams are will do that. Basically, they build the models, they put it publicly. They users used to contribute to increase the accuracy of that model, and they sometimes make it publicly available free of cost, like say open source models. Sometimes they will come up with a support kind of a services for that model. Those are business implementations, even from edtechs also.
Yeah. Thank you.
Right. Yeah, Chandrasekhar, please.
So if as a business person, let's say that I have a business plan, and is there any tools or solutions available in market which says that to execute on this business plan, you have these set of use cases, and these are the best models to be used from these vendors, right? To ease up the whole build out.
Right. I think the easiest way is you can go with a chat GPT kind of a thing and work with that. The other way is looking for papers which are already published, and see which business success based on what kind of a tools they have used. Read if we can go through, then it's a best solution normally. Yeah, and if you ask me, is there any framework? There are few, but we need to, based on our requirement, based on our business context, we need to search for it. Publicly or known kind of a frameworks, I'm not really aware at this point. Yeah. Thank you. Let me move now. There is a question. Okay, Sam, I saw your question. I have a slide for this to address. Okay, I will address, this is my last slide in this entire PPT. I will address this. Thank you. Now, coming back. So Cloud Foundation, we understood that if we are getting on demand over the internet, all these things, which is a cloud part, and which has a elasticity enables from the backend. Now, how these cloud, I'm just moving a bit deeper into the systems. Now, how this cloud is evolved, how it is implemented in the backend. Okay, so if I move back to 15, 20 years back, how a traditional machine architecture looks like. This is how it is. Even our laptop currently is in this architecture. You will have a hardware, like say your keyboard, mouse, these are physical and not logical guys, not logical hard things, but your memory, your CPU, your hard disk, your network are your main resources which are currently mainly used within the hardware, your laptop. On top of that, your operating system, maybe your Macintosh, Linux, Ubuntu, or any Linux operating system, or a Solaris, Sun Solaris kind of an operating systems. Okay. On top of that, we will be having our application. Okay. Let me take one application, like say Amazon's e-commerce application. So this is how previously it is. Even Amazon, it is like this previously. Okay. Hardware, operating system, and on top of it application. Now the problem in this is, like say for example, my hardware is a 16 GB RAM, having a 8-core processor, having a 50 GB of a storage, and my application is working fine on this. But now I just want to I got another project or need to implement a new application, this server won't work for me. I need to go and procure another server for my second application. Similarly for third, similarly for fourth. But to place all these servers, a small servers in the data center is a big issue. Because I'm consuming power, I'm consuming, electricity, cooling power, also the administrator's task, everything is there, right? Now, the opposite way. If I go and purchase a big server, like say a 64 gig of a RAM, having a 40 virtual cores of a CPU, having a terabyte of a storage or a 40 terabyte of a storage, a giant server, let's say, okay? Now, my application need a 16 GB of RAM or a 24 GB of RAM and a 8 core processor and a 100 GB of a storage. Rest of the space is not required for me. Then what the case is, my application is using part of my hardware resources. I need to use my rest of the hardware by deploying another application here, or multiple applications on the same operating system. The problem here is the application sitting on the same hardware with using the same operating system can't run on a same IPs and same port numbers also. Okay, like say for example, I deployed an application here, googleearth.com. Okay, where there is a Google Earth application which is running. I also need to deploy a gmail.com here. Okay, all the Google components I'm talking about, a gmail.com, and also need to deploy Google Drive. I also need to deploy Google Colab. I also need to deploy Google Photos. Likewise, I need to deploy all the applications within one hardware by using one operating system. The problem here is the applications are sharing the same operating system's capacity. First thing, when I say capacity, the IP address of it, network IP address, the port numbers of it, each application need one port in the backend. Okay, network protocol port is required. But if I'm using port 80 for my Gmail, I can't use port 80 for my Google Colab. So googlecolab.com:8080, it should work on some other port number. Okay, then only the application will be up and running. So these are the few cases which we are facing at that point. And my hardware is not fully utilized or, fully, utilized basically in this case. That's where the systems, in the companies came up with a new technology called a virtualization layer. Okay, virtualization layer. What exactly this will do? This will sit on top of a hardware. This will sit on the top of a hardware, a tiny software basically. Okay, this will talk to with the hardware kernels. Here, the operating system is doing the job, talking to the hardwares, the kernels, by using the operating system kernels. But here, no need of operating system. This particular tiny piece of a software, which is a virtualization layer, used to talk to the hardware and get the resources to the top. So on top of that, there is a feasibility here. I can install multiple operating systems like this. So my hardware now is previously I'm talking about a giant server as a 64 GB. In this case, now the giant servers are 1 terabyte of a memory, 1 terabyte of a RAM. I am talking about here. I'm talking about 8 GB and 64 GB. Here I'm talking about a 1 terabyte of a RAM, 800 cores CPUs, having a 20 let's say exabytes of storage connected to this hardware. Okay, like that's a giant machine in this case. Now on top of this, I can create a virtualization layer. I can install n number of operating systems until my hardware supports up to. Okay, so if I have a 1 terabyte of a memory, I can have like say 1,000 1 GB servers on top of it, right? 100 GB servers on top of it, right? Memory on it. So that's how I can increase the operating systems. And there is no network limitations also. I can have a multiple network cards, multiple IP addresses, virtual IPs will be assigned to these each operating system. No need to, there won't be any port issues also. So this is what a new technology came in 98, I think, if I'm not wrong. Virtualization layer came there, which was introduced by VMware. Okay, previously it is not that. VMware is an organization which came with a virtualization technology. Later, there are multiple companies like say IBM, Oracle, Microsoft, Google, their own hypervisors they came up with. Even there are open source like say Oracle VirtualBox kind of virtualization layer technologies are there. where we can use free of cost also, like say Xen, Linux based hypervisor, which is a virtualization layer. Even we can install our laptop also and then use it. This is the technology which is used in cloud. So now when you go to the cloud portal and when you request for a operating system with, like say, Ubuntu operating system with 8 GB of RAM with a 4-core CPU, it will give you in less than 2 to 3 minutes, because the hardware is readily available, the virtualization is readily available, the layers are already available, the resources are readily available. When you deploy an OS, the OS will be deployed directly and the resources will be assigned to you within 2 to 3 minutes, and you can deploy app on top of it, right? That is what used in cloud, right? Any questions in this? Virtualization adds nice flexibility, but any sacrifice in terms of performance and security? No. So that is enhanced basically, Sam, in this case. So here, the security is at a hardware level, at an operating system level. Now here, hardware, virtualization level, and OS level also. So 3 layers are added, and at every layer, the security is enhanced, right? And no sacrifice here. The only sacrifice here is you are not owned the server which is given to you on cloud. That's not a dedicated hardware to you. In a technology we call it as a bare metal. The metal is not assigned to you here. The metal is shared across the organizations. That is only one thing which you are compromising. But if you feel that no, I need my hardware separately for my organization, and I can deploy multiple servers on my virtualization layer, and you can do that, where you can select in cloud. When you go to the portal, AWS or Azure, there will be an option for you where you can select a bare metal, which the hardware itself will assign to you. No one will be using that hardware except you, right? This is what we will be getting. Except that bare metal sharing with other organizations, rest all are enhanced. Does that make sense? Yep. Right. Let me move to the next slide.
Sir, when you have the dedicated bare metal, does it become a private cloud in that context?
No, private cloud is a private network totally.
Oh, okay.
Okay, it's not only a hardware, also the network. Okay, so that internet which is coming to the data center will be separated to your network totally. So no other organization will use your internet in the data center. The data center network is dedicated to you.
Got it. This is only for the dedicated infra provisioning.
Yes, exactly. Right. Now, coming back, so there are, Prince, please go ahead. You are in mute if you're talking, Prince.
As you just mentioned that we can acquire a private space where I'm having all the applications and everything are deployed. Because recently I have heard a term which is called cloudlet. Is that you talking about? Is it something the same or it's different?
Well, can you repeat it? Cloudnet.
Cloudlet. LET. Cloudlet.
I need to look into it, because the terminologies, as I said before, the concept may be same across the providers, but they name it differently. I'm not really sure. Cloud let is from which provider?
GCP site, basically Google Cloud provider, because recently our bank has started putting a network within the small area of it. So specifically into portfolio management side, where I saw they are implementing Cloudlet. I'm not very much sure about it, what exactly it is, but this is a terminology that I have heard a lot there.
Right. It's it. I'm looking for that.
So it's pretty similar, right?
Cloudlet is a concept in edge computing, a small scale mobility enhanced cloud data center located at the edge of the internet to provide low latency, high bandwidth. Looks like something different, not GCP based cloudlet.
Okay.
Let me look into it and then come back in what context that cloudlet is talking about.
Perfect.
Okay. So now cloud services, different service models they have provided. Now, before getting into this, I just want to quickly tell you a story about how this cloud came in and all. Very quickly, like in 1988 or 89, I think, I'm not correctly sure about the year, but in 80s basically, sorry, 1980s. So when IBM is deploying multiple projects at multiple regions and locations, they used to use a different infrastructure for their products, but the infrastructure is not sufficient for a particular product, and they just want to get it from another department within the same organization, where which is difficult for them to share these things. But the IBM then came up with a different technology, as I said, hypervisor. They came up with a different naming tool where they shared the resources with another project when they are not using it. Okay, so that's the initial cloud which IBM started creating such kind, but not to the outside of their organization, only for their in-house employees and stakeholders. So that's the first step which was started for cloud. But later, which it came into the market by AWS. Okay, now everyone know that AWS by now, I think it's almost like 17 years they introduced this cloud. Okay, and they are the early comers into the market for the cloud providing solutions. So when everyone know that Amazon used to sell books online, library for their customers, right? So they saw that there is a heavy load on weekends, Saturdays and Sundays, because the readers who are working professionals are having their free time in the weekend, and they used to come to the online, and then they used to read the books on the weekends. But when the load is heavy on the weekends, Amazon needs to procure to serve that load a huge giant servers. But those servers are not utilized in the weekdays, because weekdays the load is very low, and all the servers are not fully utilized. So then they thought, okay, how can we utilize these servers even in the weekdays also? How can we engage them? So that's where they came up with a new thought. Why don't we give this servers which are idle at the weekdays to other companies who are working on the weekdays, like say tech companies, or any other business companies who are working on the weekdays. Let us give our services to our servers to the other companies who are working on the weekdays. That's where they started this cloud computing. But they saw that there is a very good business model or revenue model in this particular area. Then they started coming into a new naming with called AWS, Amazon Web Services, and they started this entire AWS cloud computing services. That's how it started. This is one story. There is another story, of course. I'm not really true or false about that story, because where these Amazon employees are, again, similarly like our IBM, they're sitting in a different regions. They want to work on these servers where they don't have access. Where Amazon created servers in morning times for US, and evening times for other than US candidates. They are serving the same services. That's how they started, and they started later coming up with a new cloud computing services and all. But I'm not really aware of that story. But what I believe, and which looks realistic, is about their weekdays utilization can be outsourced to any other company who are working on weekdays, utilize those servers, and then get some revenue on top of it. And that model got a big revenue, so they created a new business unit for that, which is AWS. Is what another story. Okay, so this is how cloud came into the picture, to the market, right? Now, coming back to this, now AWS started. If you are hosting your application in-house, everything, like say starting from your networking, storage, servers, your virtualization layer, operating system, middleware. When I say middleware, like say your like say you wrote a Java application, Java code, and to run that Java code, we also need a Java runtime engine, okay, and JDK to develop that. So these are like say middleware, runtime, databases like say MySQL, PostgreSQL. On top of that, your application like say your JBoss or a Tomcat application or an Apache application. These are the servers, basically application servers, databases, runtime engines, and middlewares. So these are managed by your own server administrator or a system administrator. Then it is called on-site application or an on-prem application. If you are managing end-to-end, including your network storage servers virtualization. But if someone is handling your network storage servers and virtualization, which is your infrastructure basically, okay, managed by some service provider, like say in our case, like let's take an AWS, then this is called infrastructure as a service, IaaS, infrastructure as a service, where you are not responsible for anything of these things. Okay, you're not responsible for virtualization servers and storage networking at all. They will be taking care of it. You are responsible for your operating system. You need to create a security for your operating system, updates, patches, middleware, runtime, engines here. You need to create your runtime engine. You need to create your databases, applications, everything you need to do. But this is taken care by the service provider, which is called infrastructure as a service. I'll come to the examples. Like, if you take a VM, a virtual machine from cloud, a EC2 from AWS, which falls under infrastructure as a service. Okay. Now cloud provider thought, why do we need to give a headache of patching the operating system, installing the middleware, working on the runtime, updating the runtime always? Why do we need to give all this headache to the end user? Let me take that headache and charge them for even these resources also, right? Now, cloud provider is managing all the red color boxes. Now, the end user is only handling the database and the application. This is called platform as a service. Platform as a service. Now, even they moved up and they said, no need, don't worry about even if your data, the data security is also my headache. We will take care of it. Your application, don't worry about your application. We will develop an application for you. We will provide the application to you. You just log in with your username and password and use my application, use the database, use all the downstream structures, and you run your business. You concentrate on your business. You don't worry about the infrastructure application at all. That's what cloud provider came up with. It's called software as a service, SaaS, software as a service. Now let's see the examples there. When I say infrastructure as a service, the VMs, virtual machines, what you are getting, Amazon Web Services, Microsoft Azure, Google Cloud Platform, they used to provide EC2 or virtual machines. Those are called infrastructure as a service, where the storage is given, the operating system is given, the network is given, and they are handling it. Once you got the login details of your operating system, you log into that, you install your MySQL database, you run your application on your your AI application on the Linux server there. You need to create, you are the owner for that, but you're not responsible for your VM or updates to the VM or security to the hardware. You're not responsible, right? Cloud provider is taking care of it. That's an infrastructure as a service, VMs basically. Platform as a service, like as I said before, you have a Java application with you, you developed in your laptop by using your JDK and your MyEclipse and all tools. Don't worry, I'm just getting some names. If you're not really aware of these things, not really matter also. Okay, just remember there are some softwares which you developed in your system. Now you need to deploy that in the cloud. So what you need to do, a similar kind of an environment you need to create in the cloud also. Like you need to have a hardware, VM, like say operating system, network, everything you need, which is in infrastructure. Fine. On top of it, instead of you install Java, the cloud provider will give you the Java. Instead of you run the Java runtime engine there, the cloud provider will run the Java runtime engine there. Okay, they are taking care of entire your app services also. What you need to do, you need to deploy your application, like say your WAR file directly into your cloud. That's it. Your application will be up and running, right? So another example, you developed a HTML website in your local system. Now to deploy that, there should be some application server, web application server, right? So you need to create that web application server in the cloud if you go with an infrastructure as a service. But if that platform is given to you by cloud provider, and you just put all your HTML files, .html files on top of that application, which is app as a service. Okay, so these is called platform as a service. These are called platform as a service. Google App Engine, Microsoft Azure App Services, etc. Now, similarly, software as a service. Your Salesforce, the software, the sales related software is also well prepared by the Salesforce guy. You not even developing it from your end at all. You just got a username and password to you. You log into your Salesforce website, and your account is created there. You are assigned to an organization there. You just need to save your data there, all your sales related data there. That's it. You're not even bothering about your data. Also, data security is taken care by the Salesforce. Similarly, Google Workspace, Gmail is, you logged into your Gmail account, the data is in Google. You're not worrying about the data. You're not worrying about the underlying servers and all. Everything is taken care by Google. You're just getting your Google Drive, your Google Gmail, your collab, everything you're just accessing with a username and password, and everything is there in the backend. Microsoft 365, like say Office 365. Previously it is Microsoft 365, now it is Office 365, right? So these are software as a service. Now another example, easy relatable example, you need an application, a chatbot, right? I hope everyone got you in the mind, right? Which is ChatGPT. So you are asking a question, you are getting the output. You are not even considering where it is running, what are the servers behind it, what kind of AI models are running in the backend. You're not even aware of that, right? You are asking a question, you are getting the answer, right? Perplexity, right? You're asking a question, you are getting. This is a software as a service. A chatbot as a service, which is nothing but a software as a service. Make sense? So these are cloud service model. Yeah, Prince, you have a question. Please go ahead.
So, sir, software as a service, actually, the softwares that you have just named it, basically they are very much generic in terms of, because people are just putting their details and or whatever the query that they have, just picking up the details out of that. But what about a specific requirement? For example, if I need a software which is very much specific to my business,
Right.
so in that case, what kind of services are available which I can customize and make it available for my specific task?
So at what level you are looking is the matter. Like say, for example, you are looking customizations at your application level, but your application server is a Java application server, like say your Tomcat. Okay. Then you go with a platform as a service. You customize your application at your end, but the underlying architecture is a JVM, Java Virtual Machine. So go and select drop down and then select a platform as a Java, or the platform as a .NET, and then deploy your application. The customizations are at application level, and you can go with a platform as a service.
Okay, so it means if I am having any specific application which is specific to my business, in that case, platform as a service I need to take and customize my application at into my in-house servers or something, and then deploy it on the services that I'm getting from the service providers, right?
Right. Exactly.
Okay.
Right. Okay, there is another question. Okay. Sam, the question, how should we decide which responsibilities we want to keep versus hand over to the cloud provider? When choosing between infrastructure as a service platform SaaS, I'm thinking of control, cost, speed, like a bank, like a country's population, personal national identity card system. Okay. Now, first of all, when we are considering such, bank related data where there is a security more involved, then in that case, we normally go with a secured private cloud infrastructure, first thing. Now, coming back, infrastructure as a platform as a service, software as a service. So based on our requirement, based on our team, if I have a very good infrastructure team, I will directly deploy everything on-prem. Okay, because I want to take care of my infrastructure by my IT team, where I have a more control on it. But if I don't want a control on infrastructure, I just need a control on my application, then I'll go and deploy everything on a platform as a service, because I may really not need a control on the infrastructure and on the platform. I'll go with a platform as a service and I will take those services. But I need to more concentrate on my business than my infrastructure. So I don't want to take in anything about my infrastructure at all. You forget about everything. You only concentrate on your business, sales, and marketing part. Rest of the infrastructure, rest of your applications will be taken care by software as a service. Now, coming back, are the Google, GCP, or AWS or Azure, are only the few providers are there to give you a SaaS? No, there are many, n number of organizations are there. They will be using platform as a service or an infrastructure as a service. They will build an application for you. They will manage for you as software as a service. Okay, like you can take one customized example, like what we can say, boutiques applications. Okay, I'm just taking a customized application. There is a garments boutique, okay, where a organization owner will build entire application on platform as a service, which is provided by AWS. Okay, this guy is a private guy. They build their application. Now they will give you a website or a mobile app software as a service to you, where you can upload all your boutique or or your garments images in the app, and then you sell from there by using it. Like say, you are a seller, you are using an Amazon to sell your product. Similarly, you are a seller, you are selecting any boutique application software as a service, and then you are selling your products. So you are not thinking about any application online, okay, because someone is providing you software as a service, like say shopify.com. You can think one example. You just deploy your all your e-commerce things on your Shopify, where Shopify will give the control to you. You be concentrating on your business itself. No need to think about how Shopify works in the backend. What are the e-commerce components which are involved in the backend? How the payment gateway is working in the backend? None of our business in that case. We are more concentrating on our end business solution, right? So this is one example how we can choose it. Yeah, right. Thank you, Prince. Yeah, thank you, sir. Now let me go back. Cloud value chain. So this is the same thing, yeah, cloud services models overview. This followed by this one. If you can see the hardware, I'm just deep diving in how it looks like for you is something like a Azure portal or AWS portal for you. But in the backend, what are the things happening in the backend? Okay, let me show you. So the hardware, the semiconductors are designed by someone else, Cadence, AMD, Intel, Nvidia, Synopsys. Okay, there are providers, semiconductor providers, and the manufacturing, getting those designs from these guys, and they manufacture the products, like say Intel chipset, ASML, Samsung chipsets. Okay, they are the manufacturers, and the data centers get these manufacturing components to the data centers, and they'll put this as a compute, AWS servers, Google servers, Intel servers, AMD servers. These data centers will maintain compute. Storage providers are separate again, Hewlett Packard, NetApp, Pure Storage, Dell EMC, storage providers. Similarly, networking component providers. These are all hardware providers where they collect it and create a data center. Now, this is where the cloud foundations comes in. The cloud provider will take these data centers, they access these data centers, and they will create an infrastructure on top of it, right? By creating a network security, infra management, governance, and on top of that, like compute, like Google Cloud, Azure, AWS, or Oracle, IBM. Similarly, they will create a storage network, like say from a third party again, like Cloud and Wasabi or Minio, like Minio. There are Backblaze. There are multiple storage providers. They collect these storage devices and attach to your compute in the backend. That's what the infrastructure you are getting. On top of that, when you talk about platform as a service, you are getting your app development, Doku, Salesforce kind of a thing, or Engine Yard. These are the applications which are deployed in the backend and giving it to you. But on top of it, your data platforms are there. Your Azure data platform, your Snowflake data platform, Databricks, MongoDB. These are the data platforms. Similarly, we are getting AI platforms. Your Databricks again, H2O, Dataiku, RapidMiner, Data Robot, Vertex AI, Dataiku. Like that, AI as a service, which is coming as a platform for you. Okay, AI as a service. So this is what we are accessing when we say platform. But you are accessing maybe a Databricks, but behind it, Databricks is having a storage. Databricks is having a compute where it is also connected to your networking, storage, compute, manufacturer, design. All these things you don't even know what you're using at an end user level. Everything is taken care by the cloud in the backend, right? When it comes to SaaS, that's what we just discussed. Your CRMs, your Salesforce, your Microsoft CRMs, your productivity tools like say now ServiceNow, or your Atlassian, your all your Jira tools, kind of a where you are having a username and password. You log in and you create your own testing environment, or you create your own test cases there, or you create your own bugs there. Okay, this is a bug fixing tool basically, or your version control tracking, SVN, or maybe a GitHub kind of a tools. GitHub is also a software as a service, right? GitHub. I'll be more talking about that later. Okay. So Workday, HR related Workday. Okay. These are the tools which you are getting as a software as a service. But in the back, this is how they used to maintain it. And we are not even aware what we are accessing at a front face. Make sense? Let me move. Okay, yeah, thank you, Prince. A simple thumbs up, as I said, will give me, whether you are understanding it or not. I request that. Yeah. Let me move from here. I'll be a bit even more fast because we have very less time. Now from here, why AI cannot scale without cloud? Because AI need a deployment pipeline. AI need continuous monitoring and observability. AI need continuous retraining on their models. Governance and access controls are required. So these are all well available on cloud. AI remains experimental always. You can do always, with cloud. High operational risk is there without cloud. Limited business adoption is there without cloud. So if I go with cloud, all these things will be solved. Okay, that's what the advantage. I will be now talking about all these 4 things in my upcoming slides. When I say deployment pipelines, you think about MLOps. When I say MLOps, mission learning operations. If there is a step-by-step process, your data preparation is one step, data cleaning or cleansing the data, or aggregations is called a data preparation. And once your data is ready, your model needs to be trained on this data, model training. Once the model is trained, you need to evaluate your model, whether my model is performing well on the new data or not, model evaluation. Once it is done, it's very successfully giving you the results, then you need to go and deploy it. Once it is deployed, you need to monitor monitor and maintenance, whether my model is performing well continuously or not, or the performance is coming down, and why. Okay, and of course the model performance will come down over the time. Why? I'll talk about it in my next slide. Okay, monitoring and maintenance. Once it is coming down, I need to retrain my model or replace or come up with a new model there. Okay, these are the step-by-step process in machine learning, deployment ops. Okay, now if I can write a automated script for all these things, no need to have any human in the loop at any given point. Everything need to be automated. Data should be prepared in advance. Model need to be trained on it automatically. Evaluation should be done. If the success rate is good, then move it to deployment. If the deployment is success, then start monitoring and maintenance. Now, when the monitoring is going on, if the threshold of my model, accuracy of my model is coming down less than 95, then immediately my model need to be retrained again. How it needs to be retrained? So because it reached the threshold, so I need to retrain. Or still my model is not performing well, even if I retrain, then replace the model with a new parameters, right? So this should be happen automatically. All these steps. This is called step-by-step process implemented or automated, on cloud. And this step-by-step process is called a pipeline. Okay, a pipeline. We call it a CI/CD pipeline. I'll come to that later. But for now, remember it as a pipeline. All the step-by-step process, a flow is called a pipeline. Okay, coming back. So that's called a deployment pipelines. Okay, now why do we need a monitoring and observability? I discussed about it here, right? We need to see the my model is performing well or not. If not performing, I need to move it. Why my model not perform well? I'll talk about it in the next slide. Continuous retraining, governance and access control. So this will happen only on easily without any human interface in the cloud. Okay, that's where cloud is. Without cloud, all these comes difficult in for AI. Now, enterprise AI models, enterprise AI platforms. This is what the problems are there. Challenges of isolated AI, siloed models. This is still there. Like say, I'll take a quick example again. The marketing people used to do a social media marketing for a certain targeted audience, and there is an analytics team in the backend, marketing analytics, where they used to collect that data and they used to do some analytics on top of it, and they understand something, identify some insights from that marketing data, and then they will provide it to marketing team. Again, marketing team will again start doing social media or in person or media, press media kind of marketing. But they are not connected with the sales teams. Now sales teams really know when they are selling it, they were they were really not aware of a certain people who are procuring their particular product. Okay, like say for example, a round neck t-shirt. A round neck t-shirt, mostly aged between 16 to 25 age people are procuring it. That is a commonly known for us. But if that is a unknown a kind of a thing where only a salespeople may know it, but marketing people is not aware of that. If salespeople can identify that data and give it to marketing people, marketing analytics will do that and then provide, okay, the target audience are slowly shifting. In 2023, the target audience are 30 to 35 age, or in 2020, the target audience are 16 to 25. But now the round necks, even 60 years old, 80 years old, people are also wearing the round necks. So the target audience need to be slowly shifted. So the marketing only for 16 to 25 won't work out for me if I'm only selling my product to all other age groups also. That need to be given to marketing guys. So that's where the siloed models are prepared, and they are not centralized and not used. Similarly, there are multiple things like that, like say security gaps, regulatory exposure, shadow IT teams in the backend, where they are not aware of. But if I move to the cloud and centralize the data and models, now everything is centralized. Centralized deployment, data and models, standardized deployment, unified monitoring. So I have a one interface where I can monitor entire end-to-end applications, and I have a role-based access also. Marketing people will have access only to marketing, and sales may not have access to marketing data. Or HR or finance data is not accessible to sales and marketing people at all. So a role-based access will be created on cloud, right? RBAC, we call it as RBAC, role-based access controls. So this is another advantage. Continuous model retraining. Okay. This is what I just discussed before. Why do we need continuous model retraining? Okay. The causes behind it is market shifts. As I said, in 2023, round necks are only for a certain age group, but now it got shifted to other ages also. So there is a market shift there. Behavioral changes, data drift. Okay, these are the few causes where my AI model degrade over the time. How do I solve this particular problem? I need to handle drift detection, automated retraining, and version control of my model. Okay, how do we do that? If you can see here, my static model, if I'm running it at this point, the model quality is very high here. over the time it is coming down. The model is not performing well after some time. But if I do a refreshed models, like, every 5 days, like say, based on my business model, I need to think how many days I need to consider as a period and retrain my model. So I need to create a threshold in the other way, right? Like say, for example, the results which my model is giving very good, if the accuracy is at 85, then the threshold is an 85. If my model is performing more than 85 accuracy, then my model is performing very good. But the model is not performing or getting less than 85, then immediately my model needs to be retrained. What are the cases, or on what data we need to retrain? The drift data. Like say, take an example again. So before COVID, all the businesses know a certain analysis statistics they have in the backend, and they used to run their business. But those 2 years or 3 years where COVID corona is there, the total business model got changed. They were not aware of that kind of a business environment previously. How to handle that is totally a blank, because the data is not available for such cases previously, right? But now we have that data. So my model will understand, even in that case also, the model will perform a different way, right? So the model will understand and then read the drift data, the balance data. Like say my model is trained from 2023 January to 2025 December, the model is performing well up to January in 2026. But in June 2026, my model is not performing well. So there is a shift in the data. Okay, there is a market shift in the data. Now I need to train my model on the data drift. The data drift is nothing but 2025 January to 2026 June. The data, this 1.5 year data, is my drift data, where my model need to be retrained and again get the new accuracy. If the accuracy is not still coming to the threshold point, then we need to think about the new parameters need to be added. Previously, with a n-1 number of parameters, the model is performing well. But today, this is not performing. So I need to think there needs to be some parameters need to be added to my model. And again, my model need to be trained on the new data, right? That's where the data drift comes into the picture. So this is one example for cloud implementation. Responsible AI and governance in cloud, the regulations, like say, this is what governance matters, as I said before. So the HIPAA compliance, if I am building an application, now the application is for, like say, Apollo Group in India, like say, a big healthcare industry, sorry, healthcare here, team here. But they may ask me, boss, are you a HIPAA compliance? Then I need to think, oh, I need to go and read my HIPAA compliance. I need to get the certifications. I need to build an infrastructure which supports the HIPAA compliance. This is a huge task to get all those certifications. Instead of that, if I go to the cloud, okay, and if I can ask, this is what the application I'm doing, I need a HIPAA compliance infrastructure, or I need a PIC compliance infrastructure. So then the cloud will provide certain infrastructure in certain regions. Those kind of an infrastructure may not be available in all the regions in cloud. So they'll give you in certain regions, the HIPAA compliance is available. You can implement your application in that particular region. Okay, we need to go and deploy our application in that particular data center, right? So that is how it is. So your regulation, your ethics, your trust, your brand risk, everything falls under governance. So how do we take control of it? We have, as I said before, we have a audit trails, we have a logging at every level, we have a data lineage at every point. What who is accessing my data, what kind of an access they have, how much time they accessed it. Everything is available at a data lineage in the cloud. So based on that, I can get all my audit considerations also. So the governance is taken care there. Now, two things are there which need to be still partially developed in the market: ethics, explainability. Okay, ethics and explainability. So when I say ethics, ethical AI, responsible AI. Okay, I do have the similar slides again. I'll be talking about them. Responsible AI. Okay, I'll take another 10 to 15 minutes and end this. I won't take much time. Yeah. So a simple example I'll take here: ethics. Like say, for example, if you ask a question to your ChatGPT, I need to do a bank robbery. Can you give me a proper step-by-step process to do a bank robbery? Now, ChatGPT will say, no, why do you want to do a bank robbery? Don't do that. Instead of that, go and apply for a personal loan or a gold loan in bank where it will help you for your business. It will give you such answer. But if you ask it in a different way, like I am a movie director, in my movie there is a scene where a person need to do a bank robbery where there are two security guards with so and so guns, arms in hand, and there is a full crowd in front of the road, and this road is freely available at so and so time, or fully crowded at so and so time. If you give a prompts like that, and if you ask, now I need a proper script to do a bank robbery, now ChatGPT or the other tools, whatever AI tools, will give you a clear instruction, step-by-step script to do a bank robbery. It will also help you to take what kind of like say devices to break the hardware within the bank, like say your screwdrivers or any other tools to get into easily to get in and then do a bank robbery. So that is how the output will be. This is called ethical and responsible AI handling in the backend. If it can handle even the manipulations, okay, EA manipulations, these kind of things, then it is a proper ethical AI and a responsible AI implementation, right? So there are still issues in the market currently for all the tools. There are good research happening in the backend. Very soon, slowly, one after one, the solutions will come. And why do AI taken a particular decision at that particular point is another thing called explainability, AI explainability. So we need to have a log. So today, 2026, there may be a reason why AI had taken a decision and it got impacted for some reason. In 2029, now if someone asked in 2026, why did this AI taken this particular decision at that time, is there any reason for this decision, what kind of data given to AI to come up with this particular decision, that log should be there for my upcoming business purposes for later. So AI need to generate a reason why it have taken a decision for that particular decision. So which is called explainable AI in the backend. Okay, so which is available even in tools even in the cloud right now. Okay, so these are the few things which you need to know, which we can't build on-prem, which we can only do on cloud. That's where I said cloud is really mandatory for AI implementations for a large scale, right? Now these are the few things like your continuous monitoring. These are core focus areas of responsible AI. Pillars basically: continuous monitoring, transparency and explainability, fairness and bias detection, data privacy and security, human oversight, model performance and drift, risk management, regulatory compliance, ethical use evaluation, accountability and traceability. This is auditing purpose for later. These are all pillars of ethical AI auditing. Okay, so this will help you. So now coming back again to the cloud, there are 4 types of cloud. As I said before, public cloud, of course, we already discussed. I'll quickly move. Public cloud, private cloud, hybrid and multi-cloud. When I say public cloud, scalable, cost-effective, and accessible from anywhere, which is Azure or AWS, which we are currently having. When I say private cloud, tailored control and security for your unique business needs. So this is dedicated for you and not given to anyone else. And this is yours. Maybe this private cloud is hosted on-prem or given to you by a separate provider, or given to you on a dedicated instances and dedicated network by the cloud giants. So this is a private cloud and given to you only, not given access to anyone else. Similarly, hybrid cloud. So when I say hybrid cloud, we already discussed. So something on-prem also working with something on cloud parallelly is called hybrid cloud. Seamless integration of on-premises and cloud solutions. Similarly, when I say multi-cloud, if I need two different clouds for my application, why do we need two different cloud? Any idea? Can someone guess and give me one use case? Are you with me?
Yeah, we are there.
Yes, sir.
I know the answer.
Okay. Sam, I saw that you are, laughing.
One thing I can think of, in
Please.
case if I don't want my complete infrastructure control to one cloud provider, I can have a multiple cloud providers services with me. So, for example, if I want to keep, for example, if I'm having a different line of businesses, for example, corporate investment banking, and another is for portfolio management. So I can keep the portfolio management with the GCP and the CIB with the Azure.
Right. So which is a vendor locking basically. Okay. One concept is vendor locking. You addressed a vendor locking concept. The other one, let me give you an example. So recently, all the aviation and which are using Windows servers, an year and a half back collapsed for one day for almost like 8 to 9 hours, because there is a small security update happened in the Microsoft servers in the backend, which was not well verified, and the security update patch went into the server. OS went down and all the servers went down there. Entire Microsoft went down, and the entire aviation is in hold. Your flight tickets, they just want to scan the ticket and then they need to send it to the flight. That system is not working because the servers are down. The entire aviation is down. So this is one reason. If I have that's where multi-cloud started more popular. Previously also it is there for a redundancy purpose, not for a parallel up and running, like say active and active mode. That is another use case, active and mode. My application is in Azure, also in GCP. Now if something goes wrong with the entire DNS of Azure, still my GCP will be there and solve my problem, right? This will be up and running, and then my business continuity will be there. So the business continuity is important. That's where multi-cloud came into the picture. Sweet Bajaj, please.
So could it be that both the instances are optimized for different performance? Like, for example, if you host the database separately and you host the content separately, and then one instance is optimized for like streaming of content, since you gave the Netflix and Spotify example, and then the other instance is for the database, which is the effectively the CDP or however the PIP is stored.
Right. They are, there will be an APIs, they play their own role, but there will be an APIs which fetch the data on their based on those frequencies. Yeah.
Got it. Thanks.
Yeah. Are they similar to digital twins or having a backups in multiple places? Okay, digital twins is a bit something different, where you have a physical hardware, and that physical hardware is fully implemented in a digital way. If you just want to talk about a bolt or a nut, where you can see in the digital twin image, you can zoom in and then you can get into that. That's something, a digital twin, totally a different part. That's one is a soft copy of a physical hardware. Okay. And backups in multiple places, yes. When you say, I'm sorry, instead of saying a backups in multiple places, having a active servers or active passive applications in two different providers, cloud providers. When I say active, Azure will be active, Google will be active. The traffic whichever is coming in, based on the nearest server or based on the traffic, it will divert and then work with them. In the backend, there will be a seamless communication between GCP and Azure in the backend between the databases. But as an end user, for me, it won't matter at all. I don't even understand where my it is going to, right? So this is an active. The other one is an active passive. The one will be an active Azure. The GCP will be in passive mode, where I'll be charging only for my storage, not for my applications. If Azure went down, immediately my GCP will up and running, and my traffic will now move to GCP instead of to Azure. This is another way of looking into it. Right? So multi-cloud has a multiple scenarios to handle it. Yeah, that's what went on, to address your question. Now, let
So,
me.
sir, the cost will go up significantly,
Of
right?
course,
In such a scenario when you have.
of course, that's a big issue basically. If you are maintaining, two different environments in two different clouds basically, and there is a internet pipeline which is communicating between these two, which is a huge data transferring between two cloud providers. That itself is a huge cloud cost. Yes, cost is involved. So until unless your business really need it, you should not go for a multi-cloud.
Understood.
Yeah.
Thank you, sir.
Yeah. I already went through it. These examples quickly. Large enterprises like Netflix, which uses AWS for their content and Google Cloud for their big data analytics. All the analytics happening in Google Cloud, all the content is in AWS for Netflix. So multi-cloud strategy. This is what one example, one of our participants just explained. Database is in one server, one cloud, and application is in another. Similarly, all the AI part in GCP and content is in Netflix. Similarly, hybrid, when I say banks use hybrid cloud to keep critical financial data in private cloud while using public cloud for less sensitive applications like customer support. This is one use case. In healthcare, organizations maintain a private cloud for patient data and a public cloud for research and collaboration between the organizations. So the organizations collaborate on the cloud, but the data should not be the patient data should not be moved from one healthcare industry to the other guy, right? The data remains same at their own data centers, but they collaborate on cloud for their research purpose, right? So how can do that? Just to give you one example, the model which is trained on my local data center, it will come up with a we call it as a weights. Okay, the parameters are called weights. Those weights will be passed to the cloud, and the same way the other guy also will train the model or get the weights from their data and come get that weights to the cloud. So the weights are not with the data, they're only with the parameters basically and their values, not actual data. Now, those parameters will be helpful to collaborate and work in the research environments. The data is not transmitted between these two organizations. That is how we normally do hybrid kind of implementations. Yeah. Now, cost efficient, we already discussed faster development life cycles in cloud, elastic cost models, global scalability, wherever you can host, accessible anywhere, innovation at lower risk, with very lower cost, you can do a POCs there, and then based on success rate, you can implement it later fully. Yeah, where it is a pay as you go mode, right? So cloud enables all these agile, very fast and cost efficient. And the use cases we already discussed few: healthcare, manufacturing, retail, and education. Every, all, like say education, in this case, we are using Zoom for online classes. And we are using Google Drive, I think, for accessing all the data and the videos, right? So education sector is using here, Upgrade is using here, the cloud servers, learning platforms, LMS basically. Okay. Now, these are the few industries. And the next thing is green computing and sustainability. So the cloud also maintains this green, energy efficient data centers. There are certificate providers for these data centers. They will go and audit the data centers whether they are, green cloud computing data center or not, and they will give a certificate to that. So that's where it's not even damaging our environment, right? If we go with on-prem, then we are purchasing servers and we are not even taking care of our e-wastage at this point, and all that e-wastage is creating more issues to the environment. So this cloud is taken care, the green is taken care by cloud also in this case. And followed by, these are at a very high level, I'll give you the terminology, but I'll more talk about these things in my upcoming sessions. Modern cloud architectures are like, say, virtualization, which we already discussed, containers, microservices, and DevOps. Okay, containers and microservices. There are few questions. I'll touch them, at a very high level right now. When I say containers, let me see. Okay. When I say containers, previously, as I said, we have a virtual machine, infrastructure, hypervisor, and we have a guest operating systems. But in containers, let's consider this as a black box. Now we have an infrastructure. We have an operating system here. If you see operating system is not there, we have an operating system. On top of that, we have a container engine, which is a Docker engine, basically. Okay, Docker runtime engine. Now you develop application on your Docker engine and you take this as a file and give it to your deployment team. They will directly deploy it on the cloud because the cloud also will have a container engine. So you develop it on a Macintosh operating system or a Linux operating system or any other thing. It doesn't matter because you are transferring your application, your binaries, your libraries, your environment, also your packaging as a box, as a black box, and you are sharing this black box to your production team. Okay, they will be deploying on a production servers by using container engine, and they won't even touch it. It will up and run automatically. Okay, that's where containerization is easy, and the entire world is moving towards containerization because the application portability is a very easy if I go with a container. So that if I develop my application in my Macintosh and give it to you, it will still work in Windows system or a Linux system because you will also have your own Docker engine, and then you will run this container engine and this containers basically, right? So that's where containers are more popular nowadays. Similarly, we have a serverless architectures. I don't want to get into deep dive, like say traditional deployment. We discussed about virtualized deployment. We just discussed containers, like say hardware operating system, container runtime, Docker. Here is my application. I can run multiple applications on my Docker here. Okay, which will be using only one kernel with one operating system, right? This is how we are running. Similarly, these are serverless architectures or Lambda services or functions as a services, you can call it as. Okay, let's not get into this. It will confuse you at this point. Yeah. Now, coming to the next, microservices, because we discussed also microservices. You can consider this as an e-commerce Amazon website. You are logging into a web application or a mobile application. The API gateway will read that and it will send it to you the respective page. Like say when you log into your Amazon, the first page where you can see all the products is called catalog page, where it has its own database, all the product description, number of products available at this point, and what is the cost of it, all those things available, catalog and DB. Now, once you select a product and then move to shopping cart, then it moves to the next shopping cart where you have another database where your product is moved to here and stored in this particular database. Until you buy it, it will be under shopping cart. Okay, so you have a time limit also. If you won't buy this product within 3 minutes or 4 minutes, now this product will be available for others, right? In the catalog. Of course, it will be in the cart, but sometimes it may say, the products are not available right now because someone already procured it, right? So this is another thing. Now, once you are into discount, you need to select a discount option and it has its own database. Once you order, you have its own ordering and it has its own database. Payment gateway, support system, reimbursement, like, you want to cancel the product and go with a new product, or, XYZ, multiple things are there, multiple steps are there. If you can handle each application or each module as individual container, okay, microservice, then if something goes